Let's just let it go.
Well, I mean, we'll have like an hour of dead air though, so.
Yeah, well, I'll see that.
And I don't know how much space is in the cloud, right? So.
Yeah, it should be okay. I've done a 12-hour plus.
I would probably just stop recording for now.
Okay.
Sounds okay.
I think you might have to. I don't have that option. Man, let me go over there.
No problem. You go right ahead. It's all in. Just thinking. All right, colleagues, let us get started. For those of you on Zoom and those of you live, you will, generally speaking, if you're on Zoom, perhaps see one of two names, either my name, Stephen Murphy. You may see our awesome Eric Kwan, who is our AV person. So depending upon sort of how it views. The one thing I'll ask people do is to turn your cameras off if you're not speaking. And obviously, of course, to mute yourselves. And those of you live, or even those of you in remote, actually do make sure that sort of there's no volume on any devices that can be heard. Thank you. Ed has actually generously said that we can hear you online. Thank you, Ed. That's good. I appreciate that, actually. We do have also somebody else working on it. I hope that was can, not can't. If it isn't, if it is, it can't, let me know. I got the chat open. We'll go from there. We do have somebody actually monitoring it here locally outside the room as well, just to make sure that everything is actually copacetic. So far so good. I'm not seeing lots of complaints coming through the chat. However, let me just open the chat up a little bit more. Stephanie, you're monitoring the chat as well? Everything good? Okay, thank you. This part's being recorded, if I can see, it's like, oh, meeting prep, there we go. I'll probably edit it out actually at the end of the day. So having everything sort of so far so good been in there, I will simply sort of say to thank you for all of you to coming. We have a really full roster today, which is fantastic, actually. A lot of early career folks in the afternoon, which is always very, very nice to have. A lot of attendees who are earlier in their career, which is part of the purpose of this Center for Applied Sciences in Ontario Protected Areas. That is one of our particular mandates and missions. So it's kind of nice that we actually have it. We have a great lineup, of course, for all day, lots of people. And of course, because we can do these things remote now, it's both more environmentally friendly as well as actually sort of a lot more logistically easy, if everything works, to actually have people come in without having to do lots of travel. Without further ado, I'm going to turn the proceedings over to Joe Bennett, who is our first speaker. And I'll be monitoring this. There's Joe. Hello, Joe. Thank you very much. You should be able to unmute. There you go. You can mute yourself, which is fantastic. I'm going to turn over completely to Joe. We'll try to give you a bit of a heads up, Joe, by chat if you're running into sort of time, but otherwise we won't try to bug you or anything like that. I'm actually going to let Joe take it over completely rather than keep talking. So we'll go from there. Whoops. Eric is going to actually do the screen here.
Okay, thanks everybody. Can I get a thumbs up from somebody if you can hear me? Oh, good. Okay, great. Thank you. So thank you very much for inviting me. I really, really appreciate this. It's a real honor to talk with you today. And I noticed a lot of people whose work I really admire and a lot of people who are just getting started. So this is going to be a really fun day. I'm a professor at Carleton University. I'm located in Ottawa, which is on unceded Algonquin territory. And today I'm going to talk about how we can better monitor and conserve biodiversity in Canada. And I like to start every talk by thanking my lab mates and collaborators and funders as well. And if you get a chance to take a picture of the icon on the left, that's a link to our lab website. And I feel really, really lucky to be working with some amazing people. And I want to thank them because a lot of what I'm going to talk about today is stuff that's been led by them. I also want to thank the funders for the work as well. So we all have a reason why we're here. We all have a path that got us here, and slides blocked by Zoom elements. Let me see if I can minimize that. How's that? A little better? Hopefully that's all good. I just minimized the pictures. So we all have a reason why we're here. Obviously, we're not in it for the money. And hopefully we are, we're all in it for the passion for it. And for me, that is a very linear path from where I got started to where I am now. I've done a lot of different jobs, but the motivation has been really linear. I grew up on a farm, a very marginal farm in Eastern Ontario, and there's lots of swamp and forest, and there was a pond as well. And I absolutely loved spending time with all the creatures on the farm. And I had a lot more fun, looking at them, identifying them, going out into the fields and forests than I did, for example, watching my dad fix the tractor. And so I think that's why I became an ecologist. But what has really motivated me laterally in my career is what I've seen go on since I was a little kid. And that is the disappearance, one by one, of many of the species that were in the farm where I grew up. One by one, a lot of them have disappeared. And all of the ones that I had on the top there are species at risk of extinction in Canada or Ontario or both. And one of them, in fact, is so close to extinction that I think my own children will be very, very lucky to ever see this species. And so that's why for my research and for my lab's research, the big question is always, how can we help? And our research is motivated by that. And today I'm going to talk about two branches of our research that I'm hoping can help with biodiversity conservation. These are obviously not the only branches. Lots of people could do lots of amazing things. They just are the branches that work with our area of expertise. And I'm hoping during the presentation, you can think about how your research and your expertise can help, and maybe even better, think about how maybe we could work together. So I'll talk about the first branch, improving biodiversity monitoring so we can make better management decisions. And then I will talk about the second branch, and that's figuring out where and when to make those management decisions. And as you'll see, the two of them are actually related, but I'll talk about each of them in turn. So first, we'll talk about improving biodiversity monitoring. I work on monitoring because it is so important for biodiversity conservation. It underpins so much of what we do. It is crucial for characterizing our problems to figure out what problems we have and where and when they're occurring. And it's also vital for tracking the progress of our actions as well, so that we can adapt to things and improve our management over time. And a fun thing about monitoring as well is that it can lead to just surprise discoveries. So sometimes that's a sad discovery, like a discovery of a new threat or a species that is undergoing population decline. But sometimes that is a new occurrence of a species or a new solution to a threat. So monitoring is really, really important. However, there is an important dilemma that people need to consider, and that is this monitoring versus acting dilemma, because no species or place has ever been saved by monitoring alone. Other stuff has to happen. There are even examples of monitoring that is either consciously or unconsciously used as a stalling tactic, when what needs to happen is either too expensive or too politically unpalatable. And there's even one or two examples of species being continually monitored until they were extinct. Monitoring can divert money and time away from direct action. So we need to be very careful and very cognizant of how, when, and where we monitor. So the ways our lab group is helping is developing optimal monitoring tools and better accounting for detectability and monitoring. And as you'll see, detectability is kind of very important for monitoring. So in terms of developing optimal monitoring tools, a lot of our research is anchored in what's called value of information analysis. This is a Bayesian statistical technique that originated in economics, and essentially it explores the value or influence of new information on decisions. So we can compare our best guess of our best expectation of what we might result from our management actions with current information. Then we can compare that to what would happen and what we could achieve if for some reason we had perfect information, which obviously in ecology and conservation is extremely rare, but we can compare with a theoretical value. And then we can look at what monitoring might get us. So what is our expectation that we might detect whatever the issue is if we go out and look for it, or whatever the species is, or whatever the problem is? And then how might that change our decision? We can do all of that mathematically. And what we've been doing in our lab group is expanding value of information theory for conservation. We've been looking at multi-unit and sequential problems that are really, really common in our field. So that might be which habitat patches should we monitor, and where and when should we monitor, and what order should we monitor them in, what species might we focus on, that sort of thing. And we've been relating monitoring and management costs to objectives that are not costs, because of course in our field, the ultimate objective is conserving biodiversity. And so we're relating those things because the original theory was designed to have everything be in dollars. So obviously that's not appropriate for us. So here's an example of a case study that we did, and this is monitoring versus management for rare plants. So we have a rare plant species we used as a case study. It's false root anemone. Actually occurs around Waterloo in some places, but it's a rare species. And our big question was, should we spend resources on monitoring before purchasing 1 hectare land parcels? We have estimated costs for these land parcels based on assessed values. We also have estimated costs for the monitoring as well, and we have a range of our probability of detecting that species if we go out and look for it. And the survey and purchase costs come from the same funding pool. So here is an example of how enlightening these analyses can be. On our x-axis, we have our probability of detecting our false root anemone plant. We go out and look for it. Now, we don't actually know that probability. And it turns out that for plants, it can really, really vary depending on a bunch of factors. So we modeled the entire range from 5%, in other words, we can't detect it very well at all, to 95%. In other words, we would detect it all the time. In reality, it probably ranges somewhere in the middle there. And what we can see on the y-axis is the proportion of the 1 hectare patches that we mathematically should monitor. So that's the gray bars with the Y. Is really, really low if the probability of detection is low. And that makes sense because essentially the monitoring is too expensive to be justified because it's not giving us reliable information. But once we get above, say, in this case, 0.5 probability of detection or 50% chance of finding it, if we go out and look for it, then that result really, really changes fast, and we should monitor in almost all of the cases. And so this is particular to this case study. It's not like 50% is some magic number that things change at, but it shows you how important it is to kind of look at these things and not either instinctively just monitor everything because that's kind of what we want to do, or not monitor anything because we don't want to spend money on it. It's important to examine that decision. We've also been expanding value of information theory by predicting the benefits of monitoring for model improvement and immediate decisions. So we often monitor for an immediate decision. Say, for example, an environmental assessment, we monitor to see if a rare species is somewhere and we have to mitigate or not develop. but we also monitor to improve our understanding of a system. And every time we go out and we monitor, we learn a little bit more. And so what we've been doing is try to predict the combined effects of how monitoring for one thing can improve our another thing as well. And we're designing tools to make monitoring decisions more qualitative and easy to use. Because a lot of the math underneath some of these analyses can be pretty tough, but the principles are really, really useful to use in a qualitative way for managers who are obviously really smart and know what they're doing, but just don't have time for the steep learning curve of the more quantitative stuff. Another sub-branch of our monitoring research is better accounting for detectability, because it's got really profound implications for conservation. Detectability can range from near zero to near 100% in field conditions. And both false negatives and false positives are the norm. So in other words, we can miss something if it's there, and that's really, really common. Or we can even misidentify something, and that's pretty common as well. And I think what is less appreciated is what this means for conservation. And there are a lot of ways this can really, really affect conservation. So an obvious example is not protecting an occurrence or a habitat. If we go out and look for something and we don't find it, we may assume it's not there, and then the place gets developed or something like that, or we don't protect it. That is a really, really big deal. A sort of opposite problem might be classifying something as endangered when it's not. So we might be not finding many occurrences of it at all and thinking that it's endangered, when meanwhile it's just cryptic and we can't actually find it. And that can be a problem whereby resources can be misallocated if that's the case. And then another problem could be classifying something as recovering if it's not. So if we're going out and looking for something, and in subtle ways that we don't account for or recognize, we're getting better at finding it. So we start finding more and more of it because maybe we're just getting better at what we do. We can think it's recovering because we're finding more of it, when really we're just getting better at what we do. And just generally not prioritizing resources properly can really, really affect things. For when detectability is not accounted for. So here's an example of how that might work. We have a butterfly species here. It's blue, a moth species. It's green, and they're living in a landscape that has a gradient from grassland on the top left to forest on the bottom right. If we don't account for or recognize the difference in detectability of that moth species, in the forest versus the grassland, we could end up making two big mistakes. The first mistake is we may think it's the rarer species of the two, when in reality, they're actually equally common on the landscape. The second is that we may think the top left is the best habitat, the grassland's the best habitat for it, and then we might focus on conserving that. And if we can only do one of those four squares, then we might have made a mistake, because actually the forest is better in general. It's just as good for the moth and it's better for the butterfly. So given the importance of detectability, we wanted to know how much we know about it, how much people are looking for it, using it, and what kind of a basis could people use if they're starting to take it more seriously. And what we did was a literature search for detectability estimates for 2,356 threatened species in USA and Canada. And we used threatened species because we're hoping there'd be more research on them. They've got more conservation importance. And we were looking for each species to see whether there was any paper at all, at least one paper that either mentioned a detectability estimate or tried to provide a detectability estimate or looked at detectability at all. And what we found here is in this graph, on the x-axis, we have the various taxonomic groups of threatened species. And on the y-axis, we have the proportion of those species that have at least one paper that looks at detectability at all. And what we can see immediately is there's taxonomic patterns such that birds, mammals, and amphibians have the most species that at least has one paper with detectability estimates. But Overall, 94% of threatened species in the USA and 87% of threatened species of Canada have no estimates at all in the, at least in the literature. So, you know, this is obviously a big issue. And what we want to know is what we can do. First of all, it seems obvious to me that we cannot ignore the problem. I've ignored the problem for sure in the past when I worked on the ground in management, and I don't think we can do that. We need to survey enough to know that something's not there if a decision depends on it being there or not. And that means going back a few times in some cases. Or we need to just acknowledge that uncertainty. And that suggests focusing on things like critical habitat rather than focusing on found occurrences only, focusing on critical habitat, which I think makes sense from a number of standpoints. Another thing we can do is explore new options for estimating detection rates. A PhD student in my lab, the person who took the picture of this owl, Brandon Edwards, is looking at doing that. He's working on borrowing information from bird species that have really good detectability estimates using phylogeny and traits to help provide a basis for other bird species that are either closely related or have similar traits. And I think this is a promising way forward that could work for other taxonomic groups. And finally, we need to incorporate detection rates directly into our decisions. It's really important to do that. And that doesn't necessarily mean doing the really complicated math of the detailed stuff that I was talking about, but thinking about how our decision might change if we're not detecting something, if it's there. Should we go back and look for it again? What do we think is our general probability that we're going to find the species if it's there? Is it over 50%? Is it really high if we're looking for a tree, or is it really low if we're looking for an insect species? How might that change our decision? We need to start thinking about that directly. The next main branch of research I want to talk about is, once we have our information, where and when to make management decisions. And for this, we've been designing systematic conservation planning tools. So I think it's important to ask why we should use systematic planning tools. And I think the main answer is that conservation problems are extremely complex. I put here a case of Ontario, and there's a gradient in the background here of Ontario of our species at risk of extinction in their habitats. And you can see that gradient runs from southern Ontario all the way through northern Ontario. There are fewer of them in northern Ontario, and fewer still in far north Ontario. Nonetheless, still important for conservation, but our biodiversity is largely in the south. If I was to do a gradient of land values and a gradient of difficulty in conserving an area, it would kind of closely resemble that same biodiversity gradient. So it's really hard to conserve where we have high biodiversity. And that makes things tough in Ontario, and of course in many other jurisdictions. We also have lots of governance issues. We have existing protected areas, which is helpful, but we have a lot of governance issues that need to be accounted for if we're making decisions in Ontario. There's obviously federal jurisdiction that exists or could in theory exist if certain legislation is applied. There is provincial jurisdiction as well. There are Indigenous governments and Indigenous rights and values that absolutely must be included. And then there are municipal governments as well. And so decisions are really, really complicated, especially because we have limited resources. In the current government situation we have, it's not like we have much in the way of resources for protecting land in Ontario. So we need to be transparent and accountable and do the best we can. systematic planning tools can give us baselines to compare people's alternatives. So what one person, when they work through a systematic planning process or use systematic planning tools, what they find is maybe their optimal result for what they've put in can be compared with someone else's. And they can facilitate negotiation and win-wins. I always like to say the systematic tools should never be decision-making tools. They should be decision facilitation tools. It's really important to know that some things just can't be shoehorned into a tool. Lots of cultural values and things like that cannot be shoehorned into a tool. But just like we might use Expedia to pick a flight, but we end up choosing the flight, or we might use Google Maps to choose a travel route, but we end up picking the route. Systematic tools can help us, but we should always maintain the agency in making decisions. So previous options for systematic planning tools have included intuition, gap analysis, so overlaying maps, or simple ranking, so looking at what things we think are the best and kind of moving down through the ranks. There's also been, those have a place. They are still, I think, very important in a lot of cases. But decisions are so complicated in a lot of cases that prioritization software can help. And past software has generally used simple algorithms that kind of get you close to an optimal solution, but they can be very slow as well. And what we've been looking at is using much faster, more precise algorithms. And on our right here, I put an example of a very theoretical study we did for conserving 30% of habitat for species at risk in Ontario. And that's essentially the dark red area in Ontario. And what you can see, there's lots of them, little patches in southern Ontario. But because we had land values as well, and we could use property values to estimate how much things would cost, a lot of the priorities were in the sort of south of Algonquin Park area, because things were much less expensive there, and there is some crown land that could be leveraged as well. And I don't think intuition, gap analysis, or simple ranking, or even some of the previous software could have got us there. Now, it's obviously a theoretical study, but I think it demonstrates how decision facilitation tools can help find things that might not have been intuitive. So our goals in designing our tools were to make them user-friendly, have a visual interface that is close enough to something like Google Maps or standard GIS software that people feel comfortable using them. We also wanted them to be able to find an optimal solution. So I use optimal in quotations there because it's only optimal for what is put into it. So if our data are not ideal, then the tool will do its best and it'll find what's optimal for the data. But it's important to look at a range of solutions as well. And as I said, some values need to be thought of outside of a tool. We wanted them to be open source as well, so anybody could use or modify them, and to have a fast running time. So people could look at what their budgets and then their objectives were and the data were in a meeting and compare each other's objectives and the results from each other's objectives in real time or near real time, as opposed to previous tools where it might take 48 hours to do so. And we wanted them to be flexible so they could be used on land, water, and also for not just protection and protected areas, but stewardship decisions as well. So we've designed a lot of our tools in collaboration with the Nature Conservancy of Canada. The lead designer of them is Jeff Hansen at Carleton University, and the coordinators were Richard Schuster at Nature Conservancy and me. And there was an awesome team of staff from Carleton and Nature Conservancy who produced these tools. And they were funded by, of all people, Royal Bank and also Environment and Climate Change Canada. So we've produced 2 tools, and if you want to take a photo of that link, you can give those tools a go. Just with the caveat is we've been working on the server. We needed to replace a memory and a graphics card, so they may not be working today, but they should be working at some point in the near future. So we have 2 tools. One is where to work, which is for binary decisions of protect versus not on landscape. And the second is called What to Do, which is for more complex stewardship decisions, such as where am I going to protect, but also where am I going to restore, where am I going to translocate, remove invasive species, or whatever. So the first tool, Where to Work, I think really resembles either Google Maps or ArcGIS. On our left side, we have the things we're interested in. And in this case, in the Bruce Peninsula area, we have the critical habitat for a bunch of species at risk in this case study. And we also have the locations of those species at risk. Now, in this case, the locations have a buffer around them because some of them are sensitive, so they're not the exact locations. And we have all this information on our left side, and we can look at them on a map. We can toggle them, look at where these things are. And then on our right side, we have our ability to set our objectives. So in this case, we are setting objectives, for example, for Massasauga or for Western chorus frog. And if we have certain priorities over others, we can use the sliders on the right side to set objectives higher or lower. And then we can explore ranges of things, so we can start to account for uncertainty as well. We can also weight our objectives based, for example, on the rarity of a species or what we know our agency's priorities are. And we can include things like connectivity as well. And so that can give a bunch of scenarios for people to compare and to see whose objectives kind of fit with each other and how we can find some win-wins. The next tool is, or rather the benefits of Where to Work are that it's scalable, that it works from property to global scale. And we have data, an increasing amount of data for Canada. We've used it for Canada, and it's scientific. It uses the best available data and methods. We're putting more and more data in there all the time. And I think crucially, one thing to note is that people can put their own data in, and they can run these tools on their own computers, especially if there are privacy issues. And they can explore many options, so people can compare what works for them with what works for other people. The next tool is What to Do, which has a similar interface to Where to Work, but it's for more complex decisions, such as stewardship decisions, where to restore, where to translocate, where to protect, where to purchase, where to not, where to do various different things. And so it's more data hungry and more applicable to more local scales where people have more of that local knowledge where they can start to input these things. And it works in a similar way, and it can help people sort out these really, really complicated decision issues, which I know I've worked on in the past on the ground as to where to put your efforts. And it can help provide kind of a transparent way of doing things. And some benefits of it is that obviously it can evaluate a range of actions. It can quantify the costs and benefits of actions as well, which is an important thing to do. Often when we're looking for additional funding, funders will want to know, for better or worse, what our costs might be and what our benefits might be. And so these tools can be used to help with that. And it provides a structured way of thinking about conservation actions. So before I finish the talk and we have a discussion and I answer any questions that you might have, I wanted to talk about the next steps, the way things are heading in our lab group. And that is to make things more human-centered. We've always done somewhat human-centered work, but we're really going more and more for that. And I find that personally really, really exciting, but also really, really intimidating. We're working on community science and having that more directly linked to action as well. So there are community science programs, there are community stewardship programs. We're trying to figure out where and when are these most appropriately deployed, and how can we make people feel good about what they're doing as well. We are engaging in Indigenous partnerships as well. And these are things that are crucial. If there's a area of hope for conservation, I would say Indigenous partnerships and Indigenous-led conservation is definitely one area of hope. And in a lot of cases, these relationships while so far they're successful for us, we recognize that they don't fit necessarily into a 2-year MSc or a PhD or the very kind of rigid academic system. We're also working more with private landowners, and I'm really excited about that because I'm feeling, for obvious political reasons, I'm feeling like bottom up is going to be a very, very important way to go in the future. And we're learning about how to improve public engagement. And for that, I've got to thank someone who came from Stephen Murphy's lab, actually, Tim Elemenchuk. Is a postdoc working with us now, and I'm really, really excited by all the skills that he brings. And he's also a super nice person too. And we're working on how to improve public engagement so that we can have these positive feedbacks with people doing more good, feeling about it, and then spreading the word. So I want to leave the talk with a final message. Because I've talked about what our lab group does, but I'm hoping that over the course of this short talk, you have been thinking about maybe what your skills could you could do with your skills, and maybe how possibly we could even work together. But I want people to like feel like there's something we can all do to help. It's been a tough few weeks, and it's even been a tough few months for us in the conservation field. And I want to acknowledge that, especially for the early career people in who are here today. It's tough, right? And I think it's important to acknowledge that, but it's also important to know that we have agency in our lab group. We're trying to do things with our skill set, and we're hoping that they're making an impact. And I'm sure you can too. And that is an important thing for us to keep in the front of our minds. So thank you very much for listening, and I can take questions now.
Don't worry, Joe, I hadn't abandoned you. We will have lots of time for questions actually, which is great. Stephanie, if you would monitor the ones on chat, or people can unmute themselves in there. The reason why is I don't want to monkey around the system up here. I'm not that stupid. And obviously for live, actually I'll do as well. For those of you who are live, if you want to ask a question, the easiest thing to do, honestly, is to come up to the podium, and that way you can actually be heard in the room as well as online. You got a, oh, you've got actually a mic. Okay, never mind. We actually have a roving mic. There you go. But you could be seen if you're up here, is all I'm saying. Just don't do both, right? No mic next to the other mic. Just a couple of quick remarks, Joe. That was wonderful. This is why Joe's nom de guerre is Joe Ecology. So that's pretty good, right? He mentioned actually my former PhD student, current postdoc with Joe, Tim Elemenchuk. He is indeed a very nice and excellent person. He also mentioned Jeff Hansen as well, actually. For those of you who know anything about some of the really innovative stuff in what Joe was talking about, but also just generally programs like Raptor and things like that. Jeff's been one of the big leads on all of that stuff. I mean, there's just a lot more to you can drill down to. Some of the students in this room have taken class with me or will. Jeff gets featured quite prominently in a couple of my lessons, actually, especially in the Parks Protected Area course next term, because we actually go through how to use one of the things he helped develop with people like Hugh Possingham. And again, for those who know the field, that's quite a big name like Joe is. All right, without further ado, I'll get on to the questions. Stephanie, again, you can sort of prompt me if there's anything online. And for anybody locally, fire away. We've got Joe for a few minutes here. If Joe's, oh, there we go. If we could, if you're staying put, I will repeat the question as best I can for the people on Zoom. In Précy, the question's about sort of monitoring action and sort of where do we go from here? So I'll turn it over to Joe.
Right. So monitoring and actions, where to go from here. Hey, I'm torn about it. I think we need to think about what we're doing. And we shouldn't knee-jerk reaction and say we have to monitor all the time. But we also need to recognize that monitoring is really, really important. There are examples of species recovery strategies that are 95% or even 99% monitoring. And on the surface, that's sad because these are endangered species. But on the other hand, it can sometimes be understandable if we really don't know what's going on with them. And so I think the main message is to think about what monitoring would get us and try to make sure we're monitoring in a way that helps make decisions either now or down the road, because we really are in a crisis discipline and we need to, do the best we can. And we should do the best monitoring we possibly can use the most rigorous protocols. So an example for that would be if we want to think about detectability more, keep track of the time it takes for us to do the survey. That's a simple thing to do, is start and end time for a survey. If you got enough data on that and you pool data with other people, you can start to get at things like detectability rates for species.
Thank you for the question and thanks for the answer. Other questions? We have Dan Kraus coming up. Watch out, Joe. So the two questions about incorporating conservation opportunities under uncertainty and one of the stuff that Joe was talking about, and also detectability in terms of how you make decisions, especially about things like rare species and sort of those sorts of approaches.
Right. So yeah, conservation under uncertainty. The ideal, of course, is to, if something is uncertain, then we use a precautionary principle. I think that like, for me personally, that's the best way to go. In the political climate we are in now, that is something that is kind of quite difficult. So I think in terms of monitoring for and making decisions with uncertainty, we have to be really, really clear. If, for example, as a biologist, we're called to comment on something, a development, just say, for example, development of a highway, we need to be really, really clear what we know and what we don't know and what we might be missing. And I think people need to know that just because something hasn't been found somewhere doesn't mean it isn't somewhere. And we need to start thinking about going to places over and over again. And that, for somebody who's not aware of the field, might seem weird, but it's actually an important thing to do. Hopefully that answered the questions. Dan, feel free to email me or get in touch if I didn't. And anybody else, actually, feel free to email, get in touch. I'm always happy to talk about these things.
Thank you very much. We have another question. Stephanie, is this from online? Stephanie, why don't you come up to the top? Yeah, it's just easier. Otherwise, I'll have to repeat it. So.
Cannot see. I can. Okay, I think we're gonna.
Yeah, we're gonna do it. For those of you online, we don't have a dual screen. We have one. We have Eric, however, actually here, so come to save the day. There we go. As you know, if you do extended screen, you usually have two screens. We don't have the room for that up here, so.
All right, we found the question. We have a question from Ed Morris participating online, and it is, how do you feel your conservation planning tool would work in a landscape with many remote areas that are understandably dark spots for biodiversity observations?
Oh yeah, thanks. I was just typing a response to that actually. So in remote areas, and this is often the case somewhere like Canada, we have big gaps. And so what we can do is there's a number of kind of more sophisticated things we can do, like see how our decisions might change if the species we're interested in are in these so-called dark spots. And that can indicate to us that these are real research and monitoring priorities. And we can also set our priorities, assuming they're not the dark spots are not places that would work, and see how much worse we could do than if indeed they are places that we could work. And so essentially, sorry, that's a rambling way of saying that our tools can be used to explore ranges of what we expect could possibly be in these places. And that can help us to really flag places we have to go out there and survey. So they can be used to kind of help guide monitoring efforts. And a lot of places where they are, where there isn't something can have a lot of leverage in decisions. And again, it gets back to the what I was saying before about precautionary principle as well. We, in general, need to assume that something could be somewhere if we haven't looked for it yet, or if we haven't found it yet. We need to survey as well as possible to make sure that we know if something's there.
Thank you.
We are a little bit over onto the break, which is not the worst thing in the world, but I don't want to sort of hit it too longer. I will hold the questions at that point. Obviously, from there, you can contact Joe directly. Again, thank you, Joe, very much for an excellent talk. I appreciate you taking the time out of your day for sort of doing this. For those of you online, we'll try to think a little bit about sort of what goes on, but everyone gets a break. I'll pause the recording. That's not neither here nor there, but it means for those of you who want to watch on YouTube later, actually, you won't have a 15-minute blank or one that I have to edit. For those of you in person, we do have sort of drinks and snacks around. For those of you remote, we'll be starting back on time at 10:30. Stephanie's actually going to be doing it. And I also want to acknowledge Hillary Sutton, who was the one actually sort of coordinating all the questions. Thank you very much. She's an excellent sort of person all around and a wonderful volunteer. So thank you. We will sort of stand adjourned for a few moments. Joe, again, thank you very much.
Pleasure. Thank you.
All right, everybody, alive and in person, we are here. For those of you on recording, if you're not here, well, we're recording it, so that's always good too. Without further ado, because you don't really need to hear me talk too much, we're going to talk to have our next special guest star, Stephanie Cruz Maisonet, is going to actually come here. She's doing her PhD with me, so this is sort of her opportunity to tell me all the things that she didn't want to tell me about the PhD, right? So there we go. Stephanie, the floor is yours.
All right. Good morning. Thanks, Steve, for introduction. And thank you for joining me this morning. I am excited to share some work in progress, including some findings that I'm sharing for the first time today. So looking forward to hear some of your thoughts at the end. There. As this is part of my dissertation research, I like to acknowledge the support of my dissertation committee, which includes Steve and Jeremy Pittman at the University of Waterloo, and also, thank you, and also Robert Corey at the University of Guelph. I'd also like to thank the funding sources that have helped make some of this work possible, including Casiopa, which has provided employment opportunities in research related to this area. And I would also like to acknowledge that my dissertation work happens in the context, in the physical and institutional context of the University of Waterloo, which the University of Waterloo is situated on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. Our main campus where we are today, and again, where I do my work in the environment building, not too far from here, is situated on the Haldimand Tract, in this land, which you can see in this map, is the land granted to the Six Nations that includes 6 miles on each side of the Grand River. Beyond my place of work, I've come to learn, in part due to the acknowledgements that have been made by others, that some of the places of play that contribute to my well-being are also located in on the Haldimand Tract. So well, I'm very much at the beginning of a long reflection on my positionality here as a recent immigrant and very likely a temporary visitor. I wanted to take a moment to additionally acknowledge the fact that some of these places of play, like urban parks, they are sometimes founded on the displacement of peoples and land stewards. And today I'd like to invite you to keep this thought as we continue to talk about parks throughout the day, and also invite you to look into the places where you go for connection with nature, to relax, to play, and see the history that is connected to those places. Of all types of parks, my focus is on ecological parks. Ecological parks are parks where the design of the landscape incorporates ecological knowledge to pursue benefits for people and nature at the same time. These are parks that follow specific design model with 3 common principles. The first principle is to incorporate measures for self-sufficiency. And these can refer to material sufficiency or financial sufficiency. An example would be to find that the park reuses stormwater for its water features. The second principle is that these parks seek out to provide solutions to citywide problems, and in this way they can function as infrastructure. Something that is very common in ecological parks is to look to manage flood risks. And so some of these parks are designed to be flooded. They take a different relationship with these processes. And so they allow the flood to occur and happen as just a part of what makes the park what it is. And the third principle is that the aesthetics are inspired by local identity, and that can mean it takes a reference in local ecosystems or the local culture. What we see in a lot of these parks is that they have a component of restoration, so they bring back some of that, some of the local species, native species, and also they try to do more of a participatory, collaborative design and involve stakeholders very early on to decide what the park should be like. These two principles are reflective of an overarching goal to advance the sustainability of the city, but we still don't know much about their success, whether they're hitting their marks, right? And this gap is surprising given that ecological parks arose around the 90s and have proliferated around the world following this uptake of sustainable development discourse in cities. But this is also part of a much larger and pressing knowledge gap on the effectiveness of nature-based solutions to deliver their multiple intended benefits. Understanding how these interventions are performing, however, is key in the process of monitoring progress towards international agendas, such as the Global Biodiversity Framework and Sustainable Development Goals, which set targets well aligned with the expected functions of nature-based solutions. For example, to restore degraded ecosystems, to enhance green spaces for human well-being and biodiversity, and to reduce adverse environmental impact of cities. It is also important for addressing this gap is also important for supporting implementation of contextually relevant solutions based on knowledge of where we have synergies and trade-offs, what are the appropriate and effective time and spatial scales, and when we see success, well, where is it happening and who is getting the benefits, and alternatively, who is not receiving those benefits. So as a first step in investigating the performance of ecological parks, I used a scoping review to describe the evidence available. And for that, I reviewed evidence accumulating under the concept landscape performance, which refers to the effectiveness of landscape architecture solutions to meet their goals and contribute to sustainability. This concept was coined by the Landscape Architecture Foundation, which is a organization based in the United States, in DC. And this organization has developed several resources to improve the understanding of landscape performance. For the past 14 years, they have hosted a program for case studies that evaluate landscape performance. And these case studies are available online in an open database covering several types of landscape architecture projects, including parks. So this right away presented an opportunity to study ecological parks, because there I would have multiple cases that had this chair evaluation framework, and also parks that are already oriented towards sustainability. Therefore, this was an ideal data set, of course. The cases do present some limitations, because first, they are focused on high-performing projects, meaning that they're already looking at cases that are sort of on track to meet their goals. And that means that we're missing some of the parks where we would observe underperformance. It is also a limitation that the positive outcomes are favored by the program, because they are trying to promote sustainable landscape architecture. So again, just missing some of the pieces there, potentially. And each of the evaluations is completed in a relatively limited amount of time. They have a couple of months to visit the sites, collect information, and put together an evaluation. So that means that sometimes some variables may not be, it may not be possible to assess everything, right? Regardless, this does give us a good initial set to start investigating how well ecological parks are doing. And specifically for this study, where do we see the accumulation of evidence and where do we see gaps? To find the ecological parks in the database, I screened all the cases available to identify cases that represented parks in urban areas and that had applied the 3 design principles of ecological parks. And the result of that screening was a collection of 67 case studies. These 67 parks cover 6 countries, although, as you can get from this map, they are concentrated in the US. 76% of the cases are in the States. But we do have 3 cases in Canada, all of them in Toronto. The cases cover a wide range of sizes. As you can see in the figure to the left, growing from small, under 1 acre, to very big projects over 1,000 acres. And they also cover a range of budgets, again, small budgets under less than 100,000 to over 500 million. Although here, more so concentrated between 1 million and 100 million US dollars in budget. The cases were spread across 7 climate zones, and they also range in terms of their ages, but most evaluations, 75%, were done within the first 5 years. So the evidence is accumulating about, it's capturing those first years since the design intervention. In addition, parks had diverse former land uses where although half of the parks represent brownfield redevelopment and another 16% represent the transformation of gray fields, which is good news because that means that not a lot of new land was being developed to provide park spaces. Now, within the case studies, evidence of performance can be found in the form of textual data labeled as benefits or lessons learned. Benefits are formally assessed by the case study authors and organized under categories predetermined by the landscape architecture foundations. And that can be categories like water quality or safety. On the other hand, lessons are presented as anecdotes and have no additional classification. So for that reason, identifying different types of performance outcomes in lessons learned require coding of that textual data. Nevertheless, combining both types of performance evidence was important to get a fuller picture of the results of design interventions, including some of those unintended consequences or adverse consequences, things that may be shared, again, as anecdotes in the spirit of learning and improving the design. Bringing together the benefits and lessons learned, then I found over 1,000 performance outcomes for ecological parks, and I'll begin with an overview of those findings. The evidence base shows a wide range of performance outcomes spanning 50 environmental, social, and economic categories, and an additional set of 5 categories that you can see at the far right related to landscape architecture practice. Those I won't get to cover today, but if you're curious, you can ask me at the end, of course. In this figure, I'm including all 55 categories, so of course it is difficult to appreciate them individually, but the objective here is to show you a global distribution of the observations across categories, noticing that there are high and low points, meaning that some categories are getting more attention than others. It's important to clarify here that the high points and the low points stand for, again, attention given to these categories rather than the absence of an impact of a performance outcome. Because for each case study, the authors didn't go out and measure everything that is possible within the framework. Instead, they go out and evaluate the performance of the park with respect to what is relevant and also what is possible within the time frame of the evaluation. Here, I also wanted to direct your attention to the way that assessed and anecdotal evidence contribute to this global picture. In blue, you can see the distribution of benefits, so outcomes that were originally reported as benefits. And in orange, you can see where those lessons learned add to the formal categories and also help identify new areas of attention. And in the figure, those categories are marked with an asterisk. Some of those added categories include governance and management, design costs. So that is the global picture, right? Now, because I also wanted to see how the combination of assessed and anecdotal data could offer insights into outcomes that were potentially undesirable, unintended. I also conducted a sentiment analysis on this set of outcomes. Based on a 3-class polarity scale, we observed that performance outcomes are largely positive across all performance dimensions, as represented by those dark teal green bars. This is not surprising given that benefits make up a greater portion of the combined data and that case studies are examining high-performing projects. However, we do get to capture some of those adverse outcomes. And especially when we consider individual categories, we find that some categories concentrate more of the adverse results. Note here the bars with a larger portion of that light green. We see that in categories such as plant health, management, and access and equity, which stand out as having a greater share of adverse outcomes. So now let's zoom in into these dimensions of performance. Here we have social outcomes. So recreational social value is the most commonly reported outcome overall and the top outcome in the social category. This benefit typically refers to levels of visitation and the range of recreation activities and events supported in the park, but also includes social functions such as making new acquaintances and friends and in strengthening community relations. A small portion of adverse outcomes can be observed there They're again in the light green. And these included things like unequal use of the spaces throughout the year. So some areas were intended for greater use and are not receiving as much visitation. Sometimes they are also surprised by informal uses, which can in turn create conflicts in the management of the park. And then management was the second most common social category. And this is a category that emerged as an outstanding area of performance impact once lessons learned were considered. So this is pointing out that this could become an area of attention in future evaluations. This category has a large share of adverse outcomes related to issues regarding the demand for maintenance, whether they require more time or they require specific skills to maintain the plants, etc. Also issues around the durability of facilities or the deterioration of the resource base, such as the planted areas that get impacted by high visitation. Also, sometimes the demand for visitor management. In contrast, some of the social outcomes for which we don't have much evidence yet include food production and cultural preservation. And you can see them just very small there. So only a few cases mention them. The fact that these are so little covered are not necessarily an issue themselves, because an outcome like food production would only be relevant for parks that include features for food production, like that they have a garden, right? Whereas cultural preservation stands out as a more important research target for the future, because these parks are supposed to be connecting back to the local culture of the places. Among economic impacts, the category with the higher number of reports was operations and maintenance savings. This was frequently due to a reduction in water and energy use and lower replacement needs. And parks often achieve savings through native and drought-tolerant plant species, or using a smaller irrigation areas, reusing stormwater, generating energy on-site, and incorporating facilities resilient to flooding or vandalism. Some of the lessons learned here had to do with higher than expected expenses that were still observed for plant maintenance in high-use areas, unforeseen flood impacts, and the use of potable water to supplement water fissures when they were falling short. Okay, now we have the environmental dimension of performance, which has a greater number of categories overall. And in this case, more than half of the parks reported stormwater management benefits. This connects back to what I was mentioning in the beginning. Stormwater management measures are very common in these parks. But this is not surprising. It is good to see that a large portion of those outcomes are positive. So they are effective. They're being mostly effective in managing the stormwater. And they are achieving these benefits by intercepting, detaining, and or treating on-site runoff, and at times even stormwater management from neighboring streets, roofs, and parking lots. Some of the features that they incorporated included rain gardens and wetlands and trees along with pervious surfaces. And while most of those reports indicate that the strategies were effective and so positive overall, some of the lessons pointed out that their success could be compromised by the type of ground base or misunderstanding the site drainage. Also, by invasion of unwanted plant species, or just implementing or maintaining the systems in an inadequate way. A second category that stands out here is plant health. And just like management, this is a category that emerged out of the lessons learned. So something that kept coming back in those comments. And this is all about establishment and survival of the plants. Important to consider, of course, because these parks are going for a greater portion of native species. Some positive lessons regarding plant health are worth mentioning and are related to the role of soil restoration and the removal of species or the quality of implementation in achieving high establishment and survival. Whereas most of the lessons shared struggles in sustaining grass and lawn areas due to how popular these places become, or achieving plant establishment in slope areas, or in the context of exposure to too much or too little water. Then in between these two categories I was just highlighting, we find some categories that offer insights on the impacts of ecological parks on biodiversity and conservation. Some of these categories are labeled population and species richness, habitat creation, preservation and restoration, habitat quality, and land efficiency and preservation. And what I'll do next is just share some of the findings regarding these categories to give you an idea of what the parks are, what the cases are reporting regarding these categories. Okay. For example, we have several cases that achieved an increase in species richness, several cases that also report the presence, or even better, the increased abundance of a threatened or endangered species. And in some cases, also the report of the presence of migratory birds. In a case that an example that I'm sharing here, this park in California is actually providing habitat to the locally endangered willow flycatcher. This bird is endangered in the south west of the state, so this park in California, it's having that positive impact as reported in the case study. Now, we can also learn from those anecdotes, of course. And in this case, we have a park in Toronto. This is Corktown Common, which included an urban prairie zone. They're identified with the yellow circle, where they planted initially 35 plant species. But these species were so unfamiliar to the park caretakers, to the gardeners, that they didn't know which plants to weed out and which ones to keep. And so initially, the architects observed that they had decreased biodiversity. And so for a future phase of the project, they went back and just selected 5 species that were easier for the park gardeners to sustain. This is, again, something to learn and think about these opportunities for conservation and what are the factors that can shape outcomes in highly urbanized areas, of course, it doesn't mean that this is necessarily a bad situation, because maybe what can be sustained given the characteristics of this social ecological system are the 5 species, right? For now, that's maybe the added value that this park can offer. Then considering the 2 categories that talk about habitat impacts, these categories are habitat creation, preservation, and restoration, and then habitat quality. Together, they include reports of protection of critical habitat. For example, this park in New York is protecting critical habitat for the tiger spike-tailed dragonfly. And there are additional reports of increased quality of the native plants communities and improved habitat scores or classification. This is based on several indexes that case study authors can use to report impacts. And one of the lessons learned by one of the cases was that to achieve protection of an ecologically sensitive forest area during the construction of the site, collaboration with the contractor was key. By working that relationship over the long term, they achieved that buy-in. And so the contractor, they were happy to stage the materials, to locate the materials, and carry on with the construction in a way that protected this area. So taking now a step back to look at the general status of the evidence, we find that performance evidence for ecological parks spans a wide range of categories. They tell us about a lot of different outcomes, environmental, social, and economic outcomes that these parks can have. But we do see that there is unequal attention to the categories, with some of them that are giving us a chance to be more confident about the effectiveness of certain strategies versus others where we still don't know as much. As I mentioned before, this doesn't mean that all of the categories need to be equally assessed for every park, because some of the categories are going to be more relevant than others for what the park goals are. But certainly there are some categories that would be broadly applicable, and that's where we see an opportunity for further research. In general, the documented impacts are largely positive, but we also see that anecdotal evidence starts to find those aspects where adverse outcomes can occur. And these are opportunities to learn from and to adapt design in the future. Plus, some of the remaining gaps concern the geographical coverage of this evidence base, because again, most of the cases are in the US, and it would be very helpful to learn from the application of this design model in other areas. And also to include some projects that are underperforming and see, well, why is it so difficult to reach success in those cases? Do I see opportunities for conservation in this evidence base? Well, of course. And I think here, this data set tells us about the opportunities that redeveloped sites especially can offer us to meet biodiversity and conservation objectives in urban areas. Granted, we have to put an asterisk there because we only got to see some isolated pieces of the puzzle, right? We could still use additional knowledge to understand pressures that are being pointed out in the cases, like a high demand for recreational uses, how that create conflicts, or how to tackle the inadequate, the availability of inadequate management resources, especially for planted areas. And while we can identify this need for additional data, I think here we have a prompt to look at urban parks as a potential key piece of the conservation puzzle for the future. Yeah. With that, I'd like to say thanks again, and I'd be happy to hear from you any questions or comments.
Thank you, Stephanie. I'm going to let Stephanie keep the floor here, and she can answer any questions.
Okay, actually, I am able to see a question here in the chat. All right. And the question is, how do societal challenges and biodiversity benefits balance in these ecological parks, especially important if you mention nature-based solutions? Important since species richness was not great, and were they using native species or exotic? And how would I integrate both? Okay, let's see. So the first question is about how the parks balance societal challenge and biodiversity benefits. So I would say that one of the ways is to engage in this kind of participatory design where people are involved, different stakeholders are involved from the beginning. And the teams, in some of the cases, they describe the team, the design team, and they have community members, they have experts, they have the designers themselves. So, sorry, this moved. And so I think that has been key for these parks to pursue both more complex vegetation communities in the parks in comparison to more traditional park designs, while also addressing or incorporating the way that people value different species and still want to visit these places for uses like recreation, active or passive recreation. And of course, the societal challenge of mitigating, adapting to climate change, especially this idea to let the park just flood and make it a normal part of the functioning of the park. I think it's a great way in which they are incorporating societal challenges. And then there's the second question there is mentioning that species richness was not that great, but I like to remind the audience here that, so the evidence is about how frequently it was reported as it was assessed. But if we have a little number of evaluations, that only means that more cases should be looking out to measure biodiversity and species richness, not that there was an absence of species richness. Okay, yeah. Sorry, just I think. Oh, sorry. No, yeah, that's it. I think.
All right, thank you, Stephanie, very much. Schedule a couple of minutes here. We'll just swap it over to make sure we get the AV sort of working. We have an online. Hey, if you're far away from the mic, then I'll not be able to hear it on that. Probably why.
Yeah, that could be it. Yeah.
I thought they said they couldn't see you. Yeah. That's you.
Amplitude.
Those of you in person, but also those of you online, we just swapped out microphones. For those of you online, can you give us a thumbs up if you can actually hear what the hell it is I'm saying here? Thank you, Liette. My old friend Liette Vesser has said we can hear. We had a slight microphone problem or something anyway in that side of it, so we're all good. Eric, if you would mind, we've got an online presentation next, so we'll have to go back to Zoom. That's okay? Oh, good, okay. We're all good? Okay. Thank you. Make sure I'm not sort of blocking too much. All right. Good thing we left some time for a little bit of AV tech, eh? There we go. All else being equal, we should be sort of fine on the side of it. Our next speakers are sort of all teed up. They're going to do a little sort of a joint talk. I believe Richard's going to go first. They're going to talk to us about sort of a marvelous new tool, something I'm very interested in because it's restoration. I like restoration. And that's something that we sort of get into it. For those doing the talk, you should have control over the screen. If you're having any troubles, obviously, ping us and we'll go from there. Otherwise, I'm going to turn it over to Richard and colleagues to take us home towards lunch.
Hi, thank you, Stephen. So yeah, I'm Richard Feldman, and I'm joined today by Ryan Holt and Erica Newton, and we're all from the Wildlife Research and Monitoring section of the Ontario Ministry of Natural Resources. I'm going to attempt to share my presentation. Let's see. Okay.
You were showing up very nicely, Richard.
Okay, great. Get it into slideshow view. Okay. Yeah, so thank you everyone for attending our talk, and thank you to Stephen and everyone else at Casiopa for accommodating our group in today's program. My colleagues Ryan and Erica and I are here to demonstrate our tool that we just developed. It identifies priority restoration sites in Ontario. This is actually the first time we're presenting the tool outside of our small group of collaborators, because we designed the tool to be used by the kinds of agencies, practitioners, and academics that make up Casiopa. And as such, we're very keen on receiving your feedback and hearing what you think. I'm going to give you a quick background on the science that informs the tool, and then Ryan and Erica are going to actually walk you through the tool. So if what I present doesn't make sense, hopefully it becomes clear as they walk you through the tool. I probably don't have to tell this group why ecological restoration is important, but the specific interest of the Ministry of Natural Resources stems from the various international and national commitments that some of them I've listed here, and these commitments filtering down to Ontario's own biodiversity strategy that commits to identifying priority restoration areas by 2025. There already exist great tools that help us answer the question where to restore and how to prioritize. One example I show here is from the Toronto Region and Conservation Authority. It's a really fantastic tool, but we found that a lot of the tools, existing tools, those that focus on restoring for biodiversity, which is an important emphasis, they tend to focus on increasing connectivity, or they focus on a particular species or group of species, like species at risk. We also found that a lot of tools out there looked for sites that could conserve biodiversity while simultaneously contributing to carbon sequestration and climate change mitigation. These are all important restoration goals, but we saw the need for prioritizing sites focused solely on diversity and the diversity of diversity writ large, diversity of all species, without kind of focusing on one particular taxa. We also needed a tool that could be applied across the province, and a tool with a capability for the user to define the way input data is treated and combined to then produce an outcome. The user can make changes to reflect the inherent uncertainty in what kinds of landscapes are more or less diverse. Also, different users may have different constraints on what, where, and how much to restore. And we wanted the user to be able to know how restoration prioritization outcomes change when the constraints change. With all that in mind, we wanted a tool that could tell and visualize to the user what happens or what might happen to potential biodiversity in a landscape after restoring degraded land. To operationalize the tool, we cover the province in 300 meter by 300 meter pixels or grid cells, and each grid cell is either a habitat defined by the recently released Ontario Land Cover dataset or classified as degraded land. The main way our tool operates is to turn one or more pixels classified as degraded land into habitat, one of the land cover classes in that data set I mentioned. As a result, the pixel is turned from something with zero biodiversity value to something with a benefit to biodiversity, depending on where that restored pixel is located in the landscape. All we then do is calculate the difference in landscape level biodiversity from before to after restoration. So how do we decide what pixels are degraded? We turn to the human footprint as a way of quantifying anthropogenic influence by the presence of mines, nightlights, oil and gas development, and forestry harvest. We supplement the footprint data layer with data describing aggregate and soil extraction and marginal farmland. As you'll see when we work through the tool, the user can be more or less strict in deciding how much human activity is required for a site to be considered degraded. And here are some papers already using the human footprint as a way of quantifying anthropogenic pressure, or even as a way of prioritizing restoration sites. So I keep talking about calculating biodiversity value and the biodiversity benefit of restoration. So what do I mean by that? How can we measure biodiversity, or more specifically species diversity, without any data on the species themselves? Well, I look to ecological theory that has developed over the past 60 years or so, defining the processes that determine how species can coexist, and by extension, the number of species that may be found in a landscape and in a local habitat within a landscape, and how those processes are affected by patterns, the pattern of how habitats are arranged in the landscape. More specifically, I follow what Mark Vellon has described in his book on ecological communities, where he describes three broad categories of ecological processes. These are selection, dispersal, and drift. There's actually a fourth, speciation, that we consider too slow of a process to be affected by ecological restoration. So selection describes all the ways species are affected by their environment, both the abiotic environment, factors like climate and elevation, and the biotic environment, meaning all the species interactions like competition and predation. As a simplifying assumption, we can imagine that for any given combination of environmental conditions, there is one species that performs better than all others. Its individuals survive and reproduce at high rates, and therefore its population growth is at an optimum. All else being equal, we expect the species best fit to its environment to outcompete all other species for the locally available resources. Without anything else going on, that most fit species will consume all the resources and exclude all others from the local environment. Of course, there are other things going on that allow those less fit or subdominant species to persist alongside the dominant species. One of those processes allowing coexistence is dispersal. Even if there are individuals that are being outcompeted, there are still individuals of that species arriving from areas where that species is doing better. Dispersal, of course, is also important for species that cannot get all their resources from just one location, or in cases where that even the optimal location is changing over time. Another process that affects what species may be found in an environment is drift, which is just a fancy way of saying all the random changes in birth and death rates that are unrelated to local environmental conditions or species interactions. Importantly, these random fluctuations are more likely to drive populations extinct if those populations are small. For example, if there's one bad year, maybe a hurricane comes through an area, a whole population could be wiped out if there are only a few individuals in that population. So how do we measure the outcomes of restoring degraded areas? How will we know if restoration alters selection-based processes or dispersal or drift in a way that increases diversity? We can actually measure some landscape properties and link them to each of these processes. For one, we can measure environmental heterogeneity or variability across a landscape to indicate the diversity of environmental conditions that different species can exploit. We can measure connectivity as a way of knowing the efficacy of dispersal, and we can measure the size of a contiguous habitat area, patch size, to know whether the potential for drift to affect diversity is increased or decreased. So we have a set of 3 clearly defined metrics that we can measure before and after restoration. For environmental heterogeneity, we can use a principal components analysis to describe each pixel's environment as a combination of temperature, precipitation, elevation, soil depth, and soil type. A more heterogeneous or variable landscape will have more unique combinations of these variables and therefore the potential to support more species if each species exploits a different kind of environment. We can measure connectivity by calculating the resistance an organism might face when trying to move between habitats. A landscape with many anthropogenic and degraded areas will be more difficult to traverse. And we can measure the average size of contiguous habitat patches to reflect extinction risk from stochastic forces or drift, and also to reflect where there might be more microhabitat variation that can allow species to coexist. So after restoring one or more pixels of degraded area, we can calculate if there's an increase in environmental heterogeneity, a decrease in the resistance to dispersal, and an increase in patch size. We calculate each metric before we turn degraded pixels into habitat and then after. We then create an overall biodiversity benefit by averaging the change in each metric. We allow the user to assign different weights to each of the metrics, essentially allowing some metrics to contribute to the overall score more than others. You may want to give more weight to heterogeneity if you think that your landscape has many specialized species that can be gained by restoring new environments. You may want to increase the contribution of connectivity if you think that most of the species in your landscape move around a lot to obtain resources. So maybe you're focusing your restoration efforts with the idea of looking at large mammals, for example. Finally, you may want to increase the contribution of patch size if you think there are many species with small populations, perhaps because there are a lot of species that are on the edge of their range, or perhaps there are strong edge effects, so species are sustained best when there's a lot of interior habitat. For each combination of pixels that we restore in a landscape, we can calculate the biodiversity benefit from before to after restoration, and basically choose the combination to show you what all, basically choose a combination of pixels that yields the biggest positive change in biodiversity. We can do this for multiple landscapes and then compare. So it may be, for example, ideal to restore one area in Waterloo and another in Hamilton, or there may be higher benefit from restoring 2 areas in Waterloo and none in Hamilton, if you are constrained to just restoring 2 areas across Ontario. So that's the kind of introduction to our tool. Before I turn it over to Ryan and Erica to actually show you what this looks like inside the tool, I do want to acknowledge that this work was supported by us at the Wildlife Research and Monitoring section, but also from the Biodiversity and Invasive Species section within the Ministry of Environment, Ministry of Natural Resources, and this is a collaboration between these 2 sections. So without further ado, I will stop my screen share and turn it over to Ryan and Erica.
Great, thanks so much. We're here. We're just going to take a second to share our screen and also make sure that folks can hear the audio from our screen. We did record the tool demonstration just because we wanted to make sure that we didn't run into any technical difficulties on the day of, and to just make it go a little bit more smoothly. So I'm going to try and do that now. Screen. Share sound. And again, it would be great if folks can let us know if any part of our screen is covered or if you can't hear.
Okay, so now that Richard has gone over sort of the theory behind this tool.
Can everyone hear and see that? Could I get a reaction?
In person, we can hear. You've got a bit of coverage up at the top with your toggle on and off too. You may want to minimize everything else except the presentation.
It's really funny that it's doing that. Is that better?
Yeah.
Okay, great.
Got it, friend.
We're going to be giving a demonstration step by step of how this tool can be used to look at areas of degraded land and prioritize restoring those areas based on a set of metrics. So as Richard mentioned, things like patch size, connectivity, and environmental heterogeneity.
And as we go through the tool, you might be distracted because there is a lot of text in the tool, but we're going to be trying to sum up what each step does and try and explain it pretty briefly. And we want you to know that you will have access to the tool if you desire to read those sections more fully later. So try and focus on what we're saying and just get a feel for the tool this time around.
Yeah, so this tool has several different functions, and today we're mainly going to be focusing on calculating metrics for a single landscape. And this is probably, most of you who use the tool, this is probably what you're going to be using it for. I'm looking at a single landscape, but there are other options in the tool, such as batch processing, calculating a bunch of different landscapes of a given category, or comparing multiple landscapes. But for today, we're just going to focus on a single landscape.
Yeah, so if you wanted to come in later and you wanted to use this tool to calculate the best areas to restore for every single conservation area or every single municipality, you could do that in a batch processing manner. And you could also say, look at 3 custom drawn areas that you've chosen and then compare which areas within those are best to restore. And then the last option here is to visualize any landscapes that you've previously analyzed, just to look at what they look like afterwards. Yeah, we can just choose the calculate metrics for a single landscape.
Okay, so these 2 options determine what areas are considered for the connectivity analyses in the tool. And the first option is to focus on the entire landscape. so all areas in the target landscape. And the second is to only focus on areas of conservation concern, which the user can define.
Okay, so let's say, for example, I was interested in an area south of Orangeville. I know there's a number of conservation areas in that area, and I'm interested in connectivity within those areas and between those areas. So then I would choose the entire landscape, because I don't just care about connectivity between the conservation areas, I care about connectivity overall in the landscape. So maybe we'll focus on the entire landscape.
Yeah, in that case, I think the first option would be most.
Okay.
Okay, so the next step in the app or the tool is to actually select the landscape that you're going to be analyzing. So there are several different options on how to do this. You can draw a custom landscape, or you can select a landscape from several different categories. For example, if you're interested in a particular lower municipality, you can turn that option on and it will show all the municipalities that you can select from.
Nice. Okay, well, let's maybe do the drawn area, because I know there's a number of conservation areas and reserves south of Orangeville, like I was saying. So if you turn those on and then maybe zoom in, let's draw a box around those conservation areas south of Orangeville.
Totally. Does this look okay?
Yeah, that looks great.
Okay, so another option that you have is to set a buffer around your drawn landscape. So a buffer is useful when you're looking at or particularly interested in connectivity or the cost of movement for different taxa. You might want to adjust the buffer accordingly.
Okay, so maybe if I was looking at connectivity for plants, I wouldn't need a big buffer. I could choose something small like 300 by 300 meters or 600. But if I'm looking at large mammals that might need a lot more space, and you might need to consider that, we could increase it. So maybe we'll set it to 900 today, because I'm more interested in plants, for example.
Okay, so after you've set your buffer, you click Set Extent, and that will generate your landscape. Okay, so after you select your landscape for analysis, a plot is generated, and this plot shows the habitat classes as well as their percent cover in the landscape. This gray area here, this gray border, is the buffer that you selected, and the actual target landscape is outlined in black.
Okay, so I can see like a little bit of Orangeville up there because it's gray, and so that means anthropogenic, so that's maybe the edge of the city coming down?
Totally, that would be an urban area, yeah.
Okay.
So the next main step in the app is to actually define how degraded land is classified. And so there are several different criteria to do this. For example, mines, nightlights, and depending on who's using the app, they might want to define degraded land differently.
Okay, so I guess if I considered any amount of night lights to be degraded land, I would set the slider to 1. And that would be the most liberal definition of nightlights. Whereas if I set the threshold all the way up to 10, it would mean only the brightest areas at night would be considered degraded. And we could do these with all of these criteria. So mining or forestry harvest, aggregate extraction, topsoil extraction, or undifferentiated land. So there's a lot of options here to define what you mean by degraded land.
Totally.
Okay. So I guess we'll just stick with the defaults.
Yeah, the defaults are good for now, I think. So here we click preview after we're happy with the thresholds we set, and this will output a plot showing which areas, according to the thresholds that were set, are now classified as degraded land in our target landscape.
That's a lot of degraded land. All that purple. Okay, what are the white pixels? Why are they not included?
So the white areas are areas that had habitat classes that would normally be considered not restorable. So these would be things like urban areas or farmland that is prime farmland. And for that reason, we wouldn't really think of it as something that could be restorable.
Okay, like we wouldn't want to restore city streets or people's houses in Orangeville, so that area is now gone. It's turned white.
Totally.
Okay.
Okay, so the next step in the tool is to actually simulate what degraded areas would look like if they were to be restored. And so essentially what happens to degraded areas when they're restored is they take on the natural habitat class that is nearest to them.
And then we wait.
So here you can see the simulated restored landscape. Again, this is our target landscape, and areas that were previously degraded are shown as being restored to various habitat classes, the predominant natural habitat class surrounding those degraded areas.
So it would give you an idea, if you were doing restoration, what you might want to try and restore it to.
Totally. And so there are also several options in terms of how to set the size and configuration of these restorable candidate areas. And so the first is to define these candidate areas based on chunks of contiguous habitat type. So each candidate area will be one habitat type that is contiguous. The second option is to essentially set the size and configuration of these restorable areas manually. But this will necessarily mean that not all of those restorable candidate areas are contiguous.
Okay, so the second option might do something like choosing 3 pixels, one in the south, one in the north, one in the east, if you choose it to be 3 pixels big. But that's not what I want. Like for my restoration project, I just want to choose one sort of top area that's contiguous. So maybe let's choose the first option. That sounds like it's going to be the best fit for me.
Totally. Okay, so here we are going to look at the first major metric that we're going to calculate for our target landscape, which is patch size. We're going to look at how patch size changes for each of our restorable candidate areas. As Richard mentioned, patch size is important in mitigating effects of drift for given species.
Okay, and it looks like there's also an option here where we can exclude certain habitat types when we are calculating patch size. So maybe if I was interested in a particular species or a particular suite of species, I could exclude everything but the 4 forest classes, for example.
Totally. Yeah.
Okay, so maybe today we'll just stick with the defaults, but it's nice to know that we could choose that. Okay, so it looks like the next part talks about merging patch size results. So it's saying here that if you're more interested in average patch size across all habitat types, you could just merge them. But if you're particularly interested in 1 or 2 or even 3 habitat classes, you could keep them separate throughout the analysis. And then at the end, you could choose to weight those ones higher when you're considering what's the benefit for restoration of those candidate areas. So they would make more of a difference in those calculations at the end.
Totally. So yeah, here we can see them when they're all merged, and it's one single metric. And if we don't merge them, we can see that different patch sizes are output for each different habitat class, and these can be weighted differently, as you said at the end.
Do you want to maybe just keep them as the average for now, because I don't really have a preference for this?
Totally. Okay, so the next step in the tool is to look at our second major metric, which is connectivity. As Richard mentioned before, connectivity is related to dispersal. And here we're essentially looking at how movement or dispersal might be affected by degraded versus restored land.
Okay, so basically for each metric, we're simulating restoring each candidate area that we've identified, and then looking at their performance in terms of biodiversity benefit amongst each other.
Totally.
Okay.
Okay, so after we calculate connectivity, we can see this output table here. And so this shows each of our candidate areas for restoration and the results in terms of the change in path resistance. In other words, this is sort of showing a comparison for each restored area of how easily a species might move across that landscape, measured in the change in resistance.
Okay, so candidate area 16 had the greatest change in that connectivity after you restored those pixels.
Totally.
Okay.
And so the next major metric that we're looking at is environmental heterogeneity. And a landscape that is more heterogeneous could support more species or greater diversity because it contains a greater range of abiotic microclimates. Here we're considering a number of non-biological variables such as elevation, precipitation, soil type, soil depth, and all of these might contribute to that environmental heterogeneity. Here we're using a PCA to collapse all of the information stored in these variables into two major factors or principal components. If you're interested in this, there's more detail in the documentation, but for the sake of simplicity, that's, I think, as much detail as we're going to get into.
Okay, that sounds good. So if we calculate the principal components analysis, let's do that now. It looks like the first principal component explained almost all of the variation across the landscape. So we might only need to retain one, but maybe for safety's sake, we could retain the top two, and that would kind of explain the environmental heterogeneity across our landscape and will be used further down in the app.
Totally, yeah. Once we decide how many principal components to use, what we're doing is we're essentially using these principal components to look at average surface roughness. And average surface roughness here is a representation or a measurement of the diversity of these environmental variables in the landscape.
Okay, so let's look at what happens when we calculate it across all of our different candidate areas.
Yeah, so here we can see that, again, these principal components are representing environmental heterogeneity, and surface roughness either increases or decreases depending on
what happens when you simulate restoration.
Totally, yeah.
Okay, so if we're looking at, say, candidate area 28, wherever that is on our landscape, it's 8 pixels, and it's saying here that the surface roughness or environmental heterogeneity increased when we restored that habitat. So before we restore, that degraded area has no environmental heterogeneity, and when we restored it, it meant that that area became more diverse in terms of its abiotic environmental variables. But then if you look at some other areas, it turns out that it decreases the environmental heterogeneity because maybe it added another area that has the same temperature, the same elevation as another pixel that's right next to it.
Totally. Okay, so here we're nearing the final stage of the tool, and here we're merging and scaling results. So all of the previous metrics that we calculated, patch size, connectivity, environmental heterogeneity, these are scaled so that they are comparable, and they're merged in a single table here.
Okay, so I can see each candidate area that we're considering for restoration, and then each of the metrics. And we can see here how all of those metrics have changed once we've restored that area. Now, if I want to come back to this table later to see, for example, like why was one chosen over another, or how close they were in terms of their restoration benefit, can I see this table later?
Yeah, for sure. You'll see later on this table can be downloaded and viewed outside the app as a CSV file.
Okay, that's perfect.
So here, after merging all of these metrics into a table, we can weight them.
Okay, so you're saying if I cared more about patch size, for example, I knew the species that I was interested in really needed large areas to be able to survive, I could weight that as a 2 or even a 3 if it was more important to me. So I could do that right here, just change that number, and it would change in the calculations?
Yeah, so that would change how the best candidate area would be selected based on those weights. Yeah.
Nice, so it could really be unique to me or my situation.
Totally. Okay, so in this next section of the tool, just stepping back for a moment, the whole purpose of this tool is to try to find what candidate areas might have the greatest restoration benefit. And so again, these candidate areas are ranked based on the weights that the user provides. And here, what we're doing is we're selecting, based on these ranks, how many candidate areas to display.
Okay, because there might have been like 100 of them that we were considering, but we don't want to see all 100 if we're visualizing the results. Maybe we would only want to see the top 3.
Totally, yeah. So in that case, we would set this to 3.
Okay, and then find best candidate areas.
So yeah, here this displays the top 3 candidate areas in this case, 16, 28, and 17. it displays them on this map here.
Okay, so this was, if we zoom out a little bit, that was our original target landscape south of Orangeville. And then if we want to see, like, we can see the configuration of those target landscapes, or those candidate areas rather. And then we can go to satellite view and see what's underneath them. So it looks like maybe a lot of marginal farmland. And then up here, it looks like some of the candidate areas were chosen to restore because of their proximity to a mine. And that's, or maybe topsoil extraction. And that's exactly what we're going for.
Yeah, that makes sense. And yeah, so again, this also shows our target landscape, this gray area being the buffer, and where our candidate area is positioned in this landscape and what habitat surrounds it.
Yeah, that's really helpful because in the top image, it might not always be clear what the shape is and whether it's contiguous or it's just connected by the corners. So this can really help you see what you're looking at.
So yeah, we're nearing the end of the tool pipeline here. So here we're mainly just saving the results. We can enter a name, a unique name for a landscape, and this is useful in another section of the app that allows you to compare candidate areas between different landscapes.
Okay, so I can just set that unique landscape name, and I'll just have to remember that that's what I was doing here. And
yeah, so you can save again, as I mentioned before, the results CSV with all the metrics.
Click that. Okay, it's been downloaded.
There's also the option to save a KML file in case you wanted to look at the top candidate areas, in this case, the top 3 candidate areas in Google Earth or another program like ArcGIS.
Okay, save the KML.
And then the third option here is to save a landscape visualization. So this is if you wanted to visualize this landscape at a later date, the target landscape that you selected.
Okay, I clicked that. Now I'm just gonna go take a look at both of these files. So I wanna see what the CSV looks like, and I wanna see what the KML looks like. So I'm just gonna go to my downloads folder here and open up that CSV. So it's showing me what the extent of my candidate area is, and then the name here, the name of the candidate area, and then all of my metrics. So I'm just gonna expand these a little bit so we can read them. I guess our faces might be obscuring some of this, but that's okay. So it's saying that the sum of these weighted habitat metrics were highest, so the greatest restoration benefit for candidate area 16.
Yeah, so that would be the first candidate area that we saw in the plot there.
Okay, awesome. And so then I'm gonna close this down and maybe just open up the shapes like of those candidate areas in Google Earth, because maybe I need to look at them later. So I can go just Google Earth and come into that. And then you can go to File and say Import File to Project and then Upload from Device. And I'm going to choose that KML that we just saved and press Open. And then now it will add it to my map for me. And I can again look at the satellite imagery to see what's going on behind those areas. And if you click on them, it will tell you their rank. So the label will say what the rank is in terms of the biodiversity benefit. So this was the top chosen area. I think that's it.
Yeah.
If anybody here is actually interested in trying out the tool, it's in beta mode right now, and we're still finishing it up. So what we're going to do is provide you with Richard's email address, so you can contact him if you want to obtain access to the app. Right now it's still sort of password protected. So if you email Richard, you can get the access, and then if you're going through the app and you want to leave feedback, there's this leave feedback button here, and it's present throughout the entire thing. You can click on it, and there will be a form that pops up, and we will receive all of the entries into this form. And over the next couple of weeks could add your suggestions to the tool. I'll just bring up that email one more time in case you were in the middle of writing it down. It's richard.feldman@ontario.ca.
Great. There we go. That concludes our demonstration there. So I know Richard's still a smiling face up on my screen, and we're both here. And So we're happy to answer any questions. I think maybe we have about 5 minutes if folks are curious, and really we're happy to answer anything. And just mention that Ryan really has done an amazing job at coding all of this, and it was made using R in the Shiny environment, if anyone is curious.
Yeah, and ask some questions now, but of course, just don't hesitate to email me directly or leave feedback in that with that button inside the app to get if you have any other questions or comments.
All right, thank you very much. I need to go play with that actually, better than video games. Though I think it should be called actually Smurf Restore, actually, much better name actually in my opinion. Okay, questions, of course, as usual, both in person and online. Indeed, we have about 5 minutes or so. The lunch has arrived for those in person, so you're not missing on anything. We will have at least the full hour for lunch. Stephanie, again, if you'd alert me anything that's online, that'd be fine. Hillary's got the mic. Oh, here we go. I'll repeat the question for those on Zoom. Two good questions. So one for this is for the Zoom audience primarily, but for Richard et al, just in case. One is how does the tool, if it can, deal with rock barons? That's a very good question. I deal with alvars, for example, which aren't rock barons, but still, same principle. And second of all, something I also actually have to deal with, which is things like red cedar plantations or other kinds of plantations, where they classify them sort of, as semi-natural and natural. That's not an accusation, Richard and colleagues. That's just sort of a question that we sort of can ask.
I don't know, I could start and Erica and Ryan can jump in, but so we do as a starting point use the Ontario land cover data set. So it's a new data set. There's like 22 different habitat classes or land cover classes in there. So rock barrens is one of those classes, I believe. Alvar is definitely one of the classes. And so then those are either defined as habitat, well, they're all defined as habitat, but then some of those pixels may be rock barrens, but also be classified as degraded based on those criteria we put in. So if they're degraded, but they're technically rock barren towards the land cover, but considered degraded by having these other features in there like mines or nightlights or something, and they're surrounded by rock barrens, then this act of restoration what we're looking at is what would happen if we restored this degraded rock barren pixel into a now non-degraded rock barren pixel. So Erica and Brian, did you want to
I guess
anything?
maybe there's some concern that with the human footprint layers that someone could have misclassified a rock barren as something like topsoil. And I think that's possible. I don't know if you looked at anything specific where that might have happened.
Yeah, I mean, it's tough to say. We're only sort of working with the layers we have access to, and we weren't like on the ground sort of collecting that information. But yeah, it's definitely a valid concern, I think. Yeah.
Yeah, I'm sure all the data layers we're using have some imperfections, and yeah, certainly that's why we strongly recommend looking at those recommended restorable areas in something like Google Earth or right in the app itself to like double check that, wait a second, it's saying this should be restored, but it's actually, yeah, like a rock barren and wouldn't be considered degraded.
Yeah, like
So
Joe was mentioning earlier, like, we're using the tool as a starting point, but that's why it might be important to, look at the top 10 or maybe even the top 15 candidate areas, because you want to use that human input to say, okay, yes or no.
Yeah,
I think the second question was about cedar, like plantations or other plantations. Do you know how that would be treated in the app?
Yeah, just in terms of, I don't think that is included as the habitat class. So that's something that
potentially could be like accounted for, but we would just need a data layer, I guess, identifying what is versus what is not in a plantation. Yeah, that's a good point. Yeah, I don't think that's something that we considered.
Erica Barkley in the chat is asking about whether we've considered the prevalence of invasive species as a criteria for lands being degraded, and saying that there are 2 community science data sets like EDD maps or iNaturalist that could be a source for this information, but would have gaps.
Yeah, I think, I mean, there's a ton of other data layers we could include in here. Like I've always been thinking about, so you could add in data reflecting cultural value. You could add in data recommending sort of, or demonstrating economic feasibility of restoring a pixel. So this is kind of the starting point, and then you could add in data to reflect other values besides just what we're doing here. Yeah.
Yeah, I think there would probably have to be a lot of pre-processing with those data sets to get it to sort of like a provincial layer. And again, it would be really affected by detectability like we were learning about earlier. So it's a bit dangerous, but I think it could be really valuable. So something to think about for sure.
Excellent. It's always a good reminder too, of course, is that no tool is going to be perfect, especially in sort of early stages. That's not criticism. That's sort of what happens. And it's always a good reminder, and the chat's actually been full of this from all the way to the first talk, is that, of course, there's always a question of making sure you do your ground truthing as well as everything else, actually. So there are lots of tools in Europe that do much the same thing. They're longer developed, actually, but they also have trouble with the equivalent of Alvars and so forth. Are there any other questions, Stephanie, in the chat? I'm not seeing anything up here. Are there any questions in the audience? I won't keep us past noon. Just make sure I'm respectful for everybody, including our presenters.
There's one more question. Recognizing the 300 meter by 300 meter raster, can you apply this on a very fine scale for, say, a 21 kilometer square park? You want to take that question?
Yeah, sort of just sort of thinking about what that actually means. The main limitation to using the tool is if a parcel of land doesn't have sufficient degraded land according to the definition, then you won't really have anything to simulate restoration for. But you would be able to, I think you'd be able to use the tool on a 21 kilometer square park if there was sufficient degraded land in that area to be able to simulate restoration, if that makes sense.
And there are sort of checks and balances that Ryan programmed into the tool so that when you first select a candidate, like a target landscape, it will tell you whether it's too small. Like it might not be able to calculate connectivity if there's just not really enough there for a species to move among different habitat patches, for example. So it does do that at the beginning and kind of lets you know, yeah, it's big enough, or, oh, you might need to select, you know, a bit of land around your park.
Excellent. Well, there's one last one actually, and I will allow it sort of, then we'll go with from Alistair again. Can you adjust the definitions of degraded for custom applications and or scenario modeling?
I'll start just, so we're using so yeah, we just have, you know, we're kind of limited to what data layers are out there. So right now we're using the data layers we mentioned about the human footprint, and those are the certain set of factors that are defining what the human footprint is, plus the other ones about topsoil extraction. So again, if you wanted to add in other data that inform a definition of degraded land, I mean, that would be something we would really look forward to in the future, where a user can actually import their own data. If it's right, but then you have to have the different data layers talking to each other, the projections and scale and everything. So we don't have that functionality right now to add in other layers that could inform a definition of what is degraded. I don't know if that answered the question, hopefully.
That's quite a good answer, because for those of you with R, for example, anything written in R, you can usually do bespoke applications. It's just a bugger to actually program them in. From there, I'm going to conclude it, folks. We're right at noontime, which is more or less what I felt we probably would land, which is excellent. So thank you, everybody who presented this morning. I really appreciate it, as well as the Zoom and the sort of in-person audience. For those in person, we have lunch out towards the back where you came in. There's water over there in the corner if you want it. And for those of you online, we will take a pause, of course, for the hour coming back at 1300 Eastern Standard Time. I, of course, will pause the recording so we don't end up having to watch this all have lunch for an hour or anything like that. One other small housekeeping note, because this lands on a day that I teach, I'll be actually down teaching down campus for a bit. So I'll have to see some of the talks later. Stephanie will take over as the moderator, and we do have Hillary here as well as some of other students who can always pitch in a little bit from there. So thank you very much for everybody. We will adjourn for lunch. Thanks a lot.
Okay, we're gonna get the second half of the conference started. So thank you all for joining us for the second half of the Casiopa conference. We're going to start our afternoon session with a keynote speaker address by Dr. Melanie Zerba, who is an associate professor at the School of Resource and Environmental Studies, College of Sustainability at Dalhousie University. Her talk today will be about enhancing meaningful Indigenous leadership and collaboration in international environmental and governance forums. So without further ado, Melanie, you can take it away.
Thanks so much, Stephanie. And thank you to Stephen for inviting me to this conference. I wish I could be there with you all, and really look forward to the discussion after this presentation, which I'm going to aim for a little bit shorter so we have more time for discussion. So this relates to my research program at Dalhousie University, but it also relates to a role that I maintain within the International Union for the Conservation of Nature. So within the IUCN, I have a chair position within the Commission for Environmental, Economic, and Social Policy, or CESP for short. I'll be mentioning that acronym a little bit further on. So I'll get right into it. All right, so what I'll be talking about today is part of a larger project, an international project that has multiple partners, many of which are Indigenous peoples organizations. So the organizations that were part of this project were the North Australian Indigenous Land and Sea Management Alliance, Mapawi in Honduras, Tzotzil in Guatemala, Kua'aina Ulu'uamu in Hawaii, and Isako Lam Foundation on the West Coast here, Canada. Oh, and CIPRED, Center for Indigenous Peoples Research and Development out of Nepal. CESP was also a partner, as were some academic partners, colleagues at Macquarie University in Australia and the University of Winnipeg. So this research has just recently published, hot off the press really, about a month ago in the journal Environmental Science and Policy. And I'd just like to acknowledge the co-authors here, many of which belong to the organizations that I just mentioned, as well as a number of research assistants that work with me here at Dalhousie. And while this research is international in scope, I think it really does apply to protected areas in Canada. It was born out of a project that focused on protected areas, but then took a bit of a wider lens to look at participation in a variety of different global environmental forums. So it's the first global empirical study to explore Indigenous perspectives on the barriers and challenges hindering participation within these types of forums. We reached out to a number of key informants. Our aim was to talk to as many Indigenous peoples as possible, as well as people who are working for Indigenous peoples organizations who are not always Indigenous themselves. But we also talked to other leaders and people who work in environmental NGOs who are really allied practitioners and professionals that are working with people in these spaces, and had some really great insights to offer. So our hope was to understand the experiences of the people that we talked to, but also to generate some recommendations for enhancing meaningful Indigenous participation in these forums. So just to give you a quick sense of who we talked to, so we talked to 30 participants, and these were folks who were engaged locally, regionally, as well as globally. And they came from a variety of different regions: Oceania, North America, Africa, Asia, and Europe. We spoke to 10 Indigenous participants, 3 working for Indigenous peoples organizations, and 3 non-Indigenous identifying folks working for ENGOs. And we had a fairly good gender balance in our participants. So we reached out first to folks that we knew who were involved in these forums. So I mentioned myself, I participate in these forums and knew a lot of people through that network. And then it was really a snowball sampling method to reach people who had a lot of experience in these spaces. And once we connected with them, we invited them for in-depth qualitative interviews to capture the key issues that they were facing and their experiences. The thematic coding was pretty straightforward. We mostly did inductive thematic analysis. I won't talk too much about that because I don't think that's the most interesting thing for this keynote. But just so you know that the themes were derived from people's experiences, rather than us coming in with some preconceived notions that we were applying. We really wanted it to emerge from the interviews themselves. So as we did our coding and we're going through the transcripts and trying to boil it down into digestible categories, we found that there were some main ones that were emerging. So these were first capacity barriers, and I'll be talking about all of these in detail. The second was representation, grouping, and disconnect. The third was inclusion and exclusion. Fourth was insights for how to proceed in the future. And so those were our main 4 groupings. So now I'll just go through each of them in greater detail. So we titled this category capacity barriers rather than lack of capacity, because it's important to acknowledge that the people that were coming into these spaces had a lot of capacity. They had a lot to contribute to these spaces. That's why they were invited to these spaces. But often the capacities that they brought into the international forums were a misfit, or were not adequately acknowledged, or there wasn't enough time and space given for these participants to bring their capacities forward. Limited access was an issue, so especially for in-person international forums. And this was, a very practical geographic and logistical barrier. So many of the participants mentioned that they'd like to participate. They see value in participating, but it was either too far away, not enough time, and there were even cases where people were simply not invited that they felt should have been. And once they were there in these settings, they found that their presence did not necessarily guarantee agency. And this was for a variety of reasons. So lack of familiarity with the negotiation processes they were involved with, or just no platforms at all for Indigenous peoples to negotiate. And so to kind of bring these themes to life, I've also included some of the quotes from the participants to illustrate. So this quote states, "A lot of these international forums take place in faraway places, and participation requires a large financial investment. The very nature of traveling, getting passports, credit cards, flights, navigating airports, visas, etc., for Indigenous leaders is a huge barrier. And without them being able to physically be present, then their voices are always silent." And this was from an IPO affiliated participant. Structure of the forums themselves were a big influence in how Indigenous peoples could participate in this space. And participants often emphasize the need for technological support for their presentations. So this quote illustrates this point. Indigenous leaders know at a very deep level what it means for their nation or community, but it's very disorienting, or can be very disorienting, confusing, and difficult, really, to know how to participate. They need often interpretation support. They need a lot of support with preparation and substantive technical issues, but also political implications of motions or resolutions. A little word here or there tweaked in the exact text can make a big difference in terms of how the actual meaning or implications moving forward. Language barriers were also mentioned as a limit to participation. So in many of the global forums, it's either English, French, or Spanish. And this was not always something that was easy for folks to navigate unless they had a translator that came along with them. And so it did have an influence on conveying key elements of issues, deeper meanings, conceptual depth, and so forth. The forum's Western origin put the onus on Indigenous participants to adapt and acquire proficiency rather than the forums adapting to the people that they were inviting. So Tinka John, an Indigenous leader, spoke to this point when he said, maybe the most resourceful person cannot even attend these global events because they cannot speak English or any other international languages. Financing and funding was an issue, and it was something that really maintained power imbalances between people who were invited to participate at the forums and the people that were coordinating forums. So Indigenous participants didn't always have access to adequate financing and would often be expected to volunteer their time, whereas other folks who were there representing, the larger environmental NGOs, their salaries were being covered while they were there. But for smaller NGOs, this was not always the case. Information sharing and planning of forums should always be transparent and inclusive. This was a point that was brought forward by participants quite a bit. And Western communication and formats for sharing knowledge really are quite a limitation as well in these forums too. So flexibility in presentation styles could be a potential way to open up space for Indigenous participants. And people gave examples of, only being given 5 minutes to convey something like, a very deeply rooted experience or community narrative that they felt was important to convey at that global level. But with the strict limitations that usually come in these settings, it always felt, well, it was disappointing quite often for people who were able to attend and participate. So resources like time and energy are limited for people working for Indigenous peoples organizations. And these international forums can be intimidating spaces without support. So it's important to really acknowledge that there can be, these structural inequities in the system when we're asking people to join and participate fully. And if we are inviting, then it should come with resources to support. Dr. Witness Kosanai, an Indigenous leader, spoke to this when she said, this is like being thrown in the deep end. Presentation is not something that one just wakes up one morning able to do, especially when we're talking of these international conferences. People go to university, to college to be trained on public speaking, to come up with convincing presentations. So she's really speaking to, even the more subtle structural differences in background that the people can be confronted with in these spaces. So now shifting to representation, grouping and disconnect. So this theme really refers to the fact that Indigenous peoples in global environmental governance settings are often generalized or thought of as monolithic, having similar interests, and that this often looks over their complexity, diversity, and unique challenges. Barbara Nakayangu, who is a former chair of the IUCN Natural Resource Governance Framework, spoke to this and said that I think is important from a governance perspective to consider that the next step after collective recognition is to make sure that Indigenous peoples are not romanticized, that even within them there are power dynamics. Those who come to the platform should really represent others and not just their individual interests or perspectives. So forums can paradoxically hinder Indigenous rights by applying Western concepts for measuring democracy. This quote, anonymous quote, speaks to this point. Imposing an external view of democratic, representative, or proportionality as the measure of good governance is to recolonize the space of governance in favor of the already enriched and empowered. And it is the antithesis of creating space for reconfiguring accountability in global environmental governance. So participants aim to address the lack of diversity in national and local representation. But this was challenging at times. It was especially noticed that African and South Asian countries are underrepresented and that gender and youth diversity is also needed in these spaces. And I know that's something that's being addressed across the board. There's a big youth movement in Canada, for example. And there's also a disconnect across the local, national, and global scales that hindered communication between Indigenous communities. And communities' experiences differed from national and regional policies. So as they had to navigate different scales, they were encountering different challenges and barriers as well. So the next theme is inclusion and exclusion. And participants often felt excluded from key organizations or processes leading to the development of policy. This relates to the tokenism that the participants often felt. They felt that organizations are creating spaces for dialogue, but that structural changes are really needed to ensure that Indigenous voices are brought into policy discussions. And they also thought that forums offered opportunities for empowerment and leadership, that there was high potential there, but that it just hadn't been realized yet. Tokenism was mentioned again under this theme, as it was in most themes. And in general, spaces should allow for community members to feel heard. And so adapting our typical formats is important, and we should really be taking the lead from communities, people that we are inviting into spaces. The question should be asked, how would you like to participate? So Indigenous perspectives often struggled with knowledge hierarchies and misunderstanding or misinterpretation at international forums. So concepts, issues, and values were not often fully understood, or sometimes they were underestimated. Western science continued to dominate environmental forums, or were at least privileged, especially academic knowledge. Nature-based solutions used in communities were not recognized as much, although I would say that this is definitely starting to change, especially in recent years. Although this, the folks in this study were only engaged maybe 3 or 4 years ago, so things are changing quickly in this space, but this is still definitely the perspective overall. Participants advocated for training in Western science, but bringing it together with Indigenous knowledge, which many of you may be familiar with the two-eyed seeing approach. And so this was, if it wasn't explicitly said two-eyed seeing, often participants really did see the value of both and bringing them together, but felt that Western science was being acknowledged more than Indigenous knowledge. So how to proceed in the future? Most people that we spoke to felt that collaboration and/or co-creation is essential for ensuring Indigenous peoples are part of decision-making, that it's important to create new processes, new formats at these forums, recognize capacities, build capacities, and work together. Keep bringing rights-based approaches into global forums and supporting Indigenous ownership and management of the land. and that organizations should speak up when national governments threatened Indigenous rights. It's also important to acknowledge the importance of youth and intergenerational knowledge sharing, bringing young people into these spaces to prepare them and so they can be leaders in the future. And to also empower youth to appreciate their culture and defend their rights. Dr. Sherry Pictou, who is my dear colleague here at Dalhousie University, spoke to this when she said, "There's a new generation coming and they're not going to stand by." Having said that, I think we need to improve that intergenerational transmission of knowledge, because I know that in some parts of the world, there's big concern about that, about being able to pass it on. So forums are complex, holding many different parties with many different interests. And of course, it's challenging to create the right space for everyone. But essentially, governance forums should continue striving to include supports for Indigenous leaders, mechanisms to validate diversity, recognizing existing power dynamics, and respecting Indigenous sovereignty in policy development. There should be an acknowledgement that forums need to restructure and ensure accessibility and offer support and adequate compensation to Indigenous representatives. Western partners should also receive training on cultural awareness. There should be dedicated spaces for Indigenous peoples to enhance communication. The large scale at which international organizations operate can often limit effectiveness, but forum design should consider the need of local people and be flexible to restructure. A rights-based approach is crucial to addressing complex local issues in international forums, and expanded representation and diversity, such as age and gender, of Indigenous representatives is essential. So the paper is essentially trying to provide qualitative insights to the barriers that Indigenous peoples are facing in these forums, and look at some of the colonial structures in these forums that cause misrepresentation of Indigenous peoples. It recommends a systematic and structural change to support Indigenous leadership and rights to self-determination. So thank you for your time and space and listening to. I wanted to infuse this with a lot of quotes because I think it's important that it comes from the participants. And I welcome any questions.
Thank you, Melanie. If anyone in person has any questions, feel free to raise your hand and Stephanie will bring the mic around. And we'll also keep an eye on the online forum just to see if anyone has questions there.
Thanks, Jackie. It's hard not seeing everyone. I feel like I'm by myself. Ah, thanks, Heather. I'm just noticing the chats. That's who I'm thanking. Maybe I should ask you, the audience, a question. So this was a presentation and research that came from the international scale. I'm wondering if this relates to, your national work or regional work, if you can see it reflected in your experiences.
Hi, Melanie.
Hi.
We actually had one question, and it seems that the audio was not coming through.
Oh, no, no, not at all. Completely quiet on my end.
I've invited the
Hi.
Hello. Hi, Melanie. Thank you so much for your presentation. It was really powerful and quite inspiring. And I think the points you included in your presentation were really important. So thank you so much for your presentation. I think, so my question, I think, is like at a local level, kind of when we're starting projects that are encountering lands that we're unfamiliar with and we're trying to build those connections, how do you propose, I guess, like people early on in their career to kind of, approach these Indigenous groups in order to get them in on our project, in order to have that collaboration?
Yeah, that's such a good question. Thank you for asking. It's something that early career researchers, I know they often think about it, especially if they want to work with communities and do research that's of benefit to communities. Or even, if it's not research, if say you're working for the government and it's, a project around protected areas, for example. So the approach that I've been working with for a number of years involves different steps towards making sure that we're working together at each stage, and that includes right from the inception of a project. So I know sometimes it's as a student you're coming in to a project that already exists. In that case, I would really look to your supervisors to see how their relationship building has taken place and how you can build upon that and you can learn from it, and that they can open doors towards those relationships. Now, if you're working independently and it's your first time reaching out to community partners, I always advise to start from the setting of the objectives. So it's very difficult for communities when researchers or other types of projects land at their doorstep and they haven't had an opportunity to really shape the goals of that project. And that happens, I would say, most of the time, where somebody has funding and they're like, oh, we need a community partner, or we know we're working in this region. And so I think that community partner would be ideal. And then you're really just presenting one option. So it's good to start the dialogue early, even before you have the funds, and just find out, what are the key issues that are important to the community? How can we strategize together to find funding as a team, right? So, and then at each stage of the research design, continuing to engage and ask questions. So understanding community ethical protocols, understanding how communities like to mobilize their knowledge. What are the types of knowledge products that they like to share? So yeah, and I use communities very broadly, right? This could be an organization, this could be a band council, but really starting relationships as early as possible and trying to develop a plan together rather than coming to a community and saying, would you like to be part of this thing that already exists? Hope that answers your question. Well, I'm just noticing a couple questions in the chat, but I just want to make sure I'm not cutting off somebody who's in person because I can't hear.
Yes, no, we gotta thank you for you. But yeah, we are open to address the questions in the chat. Yeah.
Okay. Further research on this topic. So yes, definitely. So what was born out of this project is an initiative called Learning for Governance. We have a website for anybody who would like to check it out. It's learningforgovernance.org. And that initiative is highlighting governance diversity, and it's aiming to bring together diverse governance actors from community, from NGOs, from governments to have dialogues and understand each other's perspectives and priorities, and even formats for how they would like to share knowledge and be engaged in the future. So that is the next step in this work, and it will have a research component, but right now we're in the action-oriented component of the initiative in developing the stories on the website. So we have a map with governance stories coming from communities across the globe. We'll also be hosting a webinar series on this. And then once there's enough engagement through the initiative, we'll then be reaching out to people and conducting some research around what came through the engagement. You know, what did they learn through it, and how those lessons can be translated into different governance spaces. And then there's a comment from Jackie. I feel like scaling down to the regional scale automatically removes some of the barriers presented at the international scale. Relationship building with local communities is more organic and conversational. Oh, for sure. Yeah, I think the international scale definitely creates another layer of complexity and challenges. I think that really came through the research. But yeah, I think I've seen this happening at different scales. Some of the challenges, especially, national still has a number of layers. And the more community-based someone is, the more contact there is and relationship building over time. Trust is a big part of this work. So I would agree with you. Yeah, absolutely. International makes it more complex.
We still have 7 minutes, so we can address additional questions. If anybody here in person would like to ask something else. And Melanie, I believe you were posing a question to us too while we were figuring out what was going on with the audio.
Yeah.
So we have an opportunity to return to that question if you can ask again.
Sure. Yeah, I'm just always interested if some of the thoughts and reflections of the participants in this research are, similar to your experiences at the national or even local level. Yeah, if anybody has experienced barriers or challenges, or even facilitators, things that have worked or have been beneficial for amplifying community voices in these spaces. I think it would be interesting to know about it.
We have somebody who will add to that.
Hi, Melanie, me again.
Hi.
I don't have a example or an answer for your question, but I guess sort of a follow-up would be when you're talking about like language barriers and having that capacity to actually have access to these platforms, when like Indigenous peoples are approaching these forums and they're bringing sort of a translator or a representative with them, how do you think, like how should the representative kind of convey the same ideas and themes that they're trying to communicate without like taking away like some of that power from the message that the Indigenous peoples are trying to deliver?
Yeah, that's a really good question, and is not something that we specifically talked about too much in the study itself, but just through my working with Indigenous peoples organizations and just folks at different levels. language is so important. This is one of the big issues with language loss, is that when you lose a language, you lose the meaning that goes alongside with that language, right? And so similarly, translation can lose meaning. And so, if somebody is trying to translate from their language into English, Spanish, or French, it may not always come through in the way they want it to, and give the full meaning of the words that they're trying to convey. So even if you have the financial support to have a full-time translator with you at one of these events, you're still encountering a barrier because of the forums only being in those 3 languages typically. And I'm not sure how to overcome that other than somehow bringing in, like more resources to convey the full richness of language as much as we can. Because unless you're a fluent speaker, you'll never get 100%. But I think there's still things that we could do at these forums. I don't know if you've been to some of the IUCN or the UN forums. It's all everybody sitting there with their little headsets, right? And it's going really, really quick, and that can be really challenging.
Absolutely. Thank you so much. Yeah, it's very interesting to see kind of, in these new platforms, like even as someone early in their career, like going into that would be very intimidating. So being from a community that's already, I guess, underrepresented, it must and with extra barriers, it just must be very difficult. So thank you for bringing a lot of those ideas to light.
Yeah, thank you for your question. And I see Jackie is mentioning mentorship in the comment here in the chat. And I agree. And this is something that the participants brought up too, that mentorship and intergenerational engagement is key really to the long-term transformation of these forums and people being able to really derive meaning from their participation. And those mentors can sometimes be allies, I think, too, right? Like, because as another comment mentions here is that a lot of communities and IPOs are really overburdened. So, there are definitely roles for allies in this space.
Right, we're ready to finish with the session then. If there are no additional questions, 1 more minute, just in case. Okay, well, Melanie, thank you so much for all the insights you've shared with us today. And stay tuned.
Thank you. Yes, thank you so much. Enjoy the rest of your conference.
Thank you.
Bye.
We'll have a short break now to switch to our next presentation, and we'll be back in about 6 minutes.
Yeah, you want to do one? Let's do it. Me? Hold on, I haven't turned this on yet. Is it good to go? Yeah.
Yeah, that was good.
Yeah.
This one. Yeah, I know that.
Hey. Sure. Yeah. I'll probably be like a full 20 minutes, but we have a lot of time, right? We have a long break.
Okay, just 1 second. I'm gonna start sharing this and then have this open right back up.
Yeah,
for you.
yeah, sure.
Okay, so our next speaker is Dr.
Definitely.
Chris Lameau, who is an associate professor and John McMurray Research Chair at Environment and Geography at Wilfrid Laurier University. The title of his talk will be The Changing Nature of Protected and Conserved Areas, Reporting Globally and in Canada. So without further ado, Chris.
Yeah, thank you. All right, hope everyone's doing well. Thanks for the opportunity to speak to you today. Bit of a tough gig at this time of the day when everyone's a little bit low on energy. And if anyone has any ideas on how to make a presentation on reporting on protected and conserved areas exciting, now's a good time to give me some tips. Okay, but it is an important issue, even if we're presenting at the wrong time of the day. But before I get going, who am I talking to? Are you all grad students? For the most part? No, raise your hand. Are you a grad student? Oh, okay, so about half. Are you an undergrad student? Okay, all right. Awesome to be here. Okay, well, I actually did my master's and PhD at the University of Waterloo. And even before that, I did my undergrad at Laurier, and it's hard to believe that, and I'm not the only one here. I have a colleague over here, but back in the mid-90s, this used to be a dance club. So it's gone from being a dance club to a conference venue. So it's a little bit, I'm having some weird images out of the audience. Okay. What's that? Yeah, no, those days are done. I'm getting old. Oh, this isn't working. Awesome. Was working. Sorry, I'm just gonna put this back in. Hopefully it goes. Of course it doesn't. Okay, should have tested that ahead of time. My apologies. Oh, and now I got, can you come up here? Sorry. Okay, I need this out of here. Why is this? Okay, I think we're working again. Okay, first thing I want to do is just acknowledge a bunch of collaborators that have worked on these projects with me over the last few years. The first at the top, Dr. Carly Cook, and we have Dr. Rachel Goldenkroner from the World Wildlife Fund. And I've collaborated with them on this paper here on increasing transparency and accountability in global protected and conserved areas reporting. And Harry Jonas from the World Wildlife Fund actually led this paper here on the global status of OECMs. Now, before I get going again, how many of you have heard, just so I know what's going on, how many of you heard of OECMs, other effective area-based conservation measures? Okay, I'll take a step back and define them for the rest of you in a second. Starting to take this for granted. It's a term that's been around for about a decade, but it's still a lot of learning occurring around that, that framework, the OECM framework. So I'll define that for you in a second, okay? In terms of a presentation overview, I will talk about the global status of OECMs and what's going on within that scene. It's not just about protected areas anymore, okay? I'll provide an overview of conserved area downlisting, delisting, and downsizing, which is something that can occur and has been going on for about 100 years or so, at least in the protected areas domain. And now that conserved areas or OECMs have been added to the area-based conservation kind of toolbox, we're starting to see that occur as well. And I'll provide you with some examples of that. Okay, and I'll once we're done going through the examples of that, I'll show you what the implications are for policy and practice, especially for protected and conserved area reporting, both globally and in Canada. And then we'll provide some recommendations at the end on how we can improve reporting, okay? Okay, so for those of you who are not familiar with the OECM framework, basically back in 2010 in Nagoya, Japan, okay, when the strategic plan for biodiversity was being negotiated by countries, which is a part of the Convention on Biological Diversity, a whole bunch of targets. There were 20 targets that were agreed to at that time. And one of them was focused on area-based conservation. Okay, and in those negotiations, which were described as being very protractive, even torturous, and they went on until 2 a.m. on the last day of these negotiations that were leading into this new strategic plan for biodiversity, a new term called other effective area-based conservation measures was included in what became Target 11. And that really changed the conservation, the area-based conservation landscape. Okay, it wasn't just about protected areas anymore. And OECMs were added as a way to recognize areas other than protected areas that provide biodiversity conservation value, okay? And again, I'll provide you a more formal definition in a second on that. Okay, but it's important for you to know that the inclusion of other effective area-based conservation measures was the focus of significant debate. There was a lot of concerns at this CBD meeting in Nagoya back in 2010 that we don't cast the net too wide, okay, and we don't compromise quality in terms of area-based conservation. Okay, so it raised both hope in the sense that these OECMs can be used to recognize, for example, areas managed by Indigenous people, okay, or some, and there's lots of emerging examples in Canada now of OECMs, including military-based lands and university research stations, so some really legitimate sites. But it also raised scrutiny in the sense that it also opens up the door to some areas that may be of low conservation quality or standards, okay? And in terms of a definition, okay, what you see on the left here is a definition. I forgot to put it in because I did take a step back about 20 minutes before the presentation to define a protected area. Okay, so what you see on your left is the definition of a protected area. A clearly defined geographical space recognized, dedicated, and managed through legal or other effective means to achieve the long-term conservation of nature with associated ecosystem services and cultural values. Okay, and in 2019, almost 10 years after the OECM framework or term was included in the language of the Convention on Biological Diversity targets, it was defined, well, I guess 2018, my apologies, I said 2019, as the following up here. So this is the agreed to definition by the Convention on Biological Diversity. You can see that there are some similarities, but in a very general sense, what makes them different, okay, is that a protected area has a primary conservation objective, and this thing called an OECM, okay, doesn't necessarily have to have protection, okay, or conservation as its primary objective. It can be a secondary objective, even a third order objective, or even an auxiliary objective, okay? But the point is that OECMs must, in the definition, deliver the effective in situ conservation of biodiversity, regardless of its objectives. And this part is really important for you to take in and consider as we go through some examples, okay? So lots of similarities, okay, in the grand scheme of things. They're supposed to be complementary and not completely different. But these, the OECM definition and the inclusion of the language around effective in situ conservation of biodiversity is really key in terms of keeping some sort of minimal conservation standard in place, okay? So what you see here on the top left is a paper I published regarding the declaration of OECMs in Canada's marine realm, okay? Departments of Fisheries and Oceans Canada were essentially the first department or agency in Canada to declare OECMs back in 2017. And that occurred first in the marine realm, okay? And we were among, Canada was among the first countries in the world to start declaring OECMs, okay? And I've been very critical of that approach, I fully admit. And myself and Dan Krause, who's here today, we've published a couple papers on this and the importance of maintaining minimum conservation standards and being transparent and accountable in the decision-making processes in terms of identifying these areas. But we wrote a paper here, and now I know the analogy sounds a little bit funny in terms of hamburger manufacturing, but back in the early 2000s, George W. Bush stirred a lot of controversy by declaring in his annual economic outlook that the US was going to create 2.6 million manufacturing jobs. And then when you look at things a little bit, you know, with a little bit of scrutiny, it was revealed that basically what George W. Bush's team was trying to do was to bend the definition of what counts as manufacturing, okay? And in that economic outlook report, it was argued that putting together a hamburger, a bun, patty, toppings, okay, and putting ketchup and mustard and things like that is actually manufacturing, because it's very much like putting together an automobile, right? You put together a car, you put in the engine, you put on wheels, and you do all these other things. And so you see lots of examples like this in other contexts. I mean, especially in the US, I mean, they tried to get pickle relish to count as a vegetable and things like that, and as a way to kind of fluff the numbers in terms of ways that work to their advantage, okay? But at the end of the day, Canada added about 5% of its marine area by converting fisheries closures, calling them marine refuges, which is, I'm not a big fan of that name. I think it's completely misleading to the public, and declared them as OECMs, okay? And these areas, for the most part, and we've been very, again, critical of these, are really low quality. Just about everything lacks strict protection. There may be a certain ban on bottom trawling or something like that, but other allowable activities, industrial or commercial activities, are allowed in it, okay? And we've warned in other papers that there's going to be spatial spillovers, right? If this is the standard that we adopt now, what's to prevent this from being adopted by other countries or even within Canada and other provinces or territories? And we actually warned of this almost a decade ago, and we're starting to see that now, okay? So just to give you an outlook of what's going on globally, okay, with respect to OECMs, only 9 countries have declared OECMs so far, and Canada is one of those. You can see that it only adds a little bit, okay, about 1% globally to the declared conserved area estate. So taking protected areas and OECMs collectively, okay? In Canada, we're around the same, about 0.9% on land, but in the marine realm, you see it's quite a bit bigger or more substantial. You've almost got an increase of about 5% once you start adding OECMs to the marine protected area estate, okay? And again, here you can look at Canada compared to other countries. These are the Aichi targets that were agreed to in 2010 that I was talking about. 10% of marine area and 17% of land area to be set aside in protected areas and OECMs. And this is what we've agreed to now. Okay, the Global Biodiversity Framework, which aims target free, which aims to protect 30% of land and marine area globally. Okay, so we've got a long way to go. Okay, but again, OECMs can be a useful tool if they're done right. Okay. When you look at the global OECM scene, there are other things to look at as well. You can see that in Canada, they're actually contributing a little bit to also the protection of key biodiversity areas. So if you look at these two bar graphs, you can see that a number of OECM sites do overlap with what are called key biodiversity areas. But then if you look at the other side here in terms of connectivity and whether or not they're adding to the connectivity between protected areas and other OECMs, that right now it's adding very little. Okay, especially compared to some of the other countries who are much more aggressive on the OECM scene than Canada is. Okay, this graph here, or chart, it's a violin chart. I'm not used to these. This is the first time that when I was part of this paper, I've seen one. But the one thing that was a big surprise when we looked at OECMs globally was that actually most of them were being declared by government, and they tended to be small, which is what you see here. You got size here, and then you got like the different governance types and the number of sites that were included in the analysis. Okay, and so there's a number of implications for that. All right. Yeah, we're starting to see these OECMs pop up. There's about 850 declared globally, but for the most part, they're really not supporting their original intent in terms of including Indigenous peoples areas and things like that, because most are being declared by government. And one of the things that we've recognized as well is that a third of these OECMs don't have any management objectives whatsoever. Okay, and there's no evidence at all to indicate that they're effective at conserving biodiversity over the long term, which is part of that definition I told you about at the very beginning. Okay, and the other thing that's interesting is that there are screening tools and guidance documents available to identify a site and put it through a whole bunch of decision support criteria. And there's almost no evidence to indicate that these sites are being properly screened and included in the World Database on protected areas. So this raises a lot of questions, okay, in terms of how we identify and report on both protected areas and OECMs, okay? So what we've noticed is that there's actually a lot going on, okay, that some protected areas are being converted to conserved areas, which is what you see here. So basically you have a protected area, now it's becoming an OECM. So OECM and conserved area are kind of used synonymously, okay? They're interchangeably, okay? And as a result of that, you can see some things going on as well, including downgrading, downsizing, and delisting. And these are the type of things that aren't adequately captured in protected and conserved area reporting right now that need to be taken into account. Like the inclusion of OECMs is really changing the way areas-based conservation occurs. So what I'm going to do is just go through a couple examples, okay, like where CA downgrade could occur. Okay, this is where human activities increase, okay, a little bit over time, okay, that are kind of deemed incompatible with the in situ conservation of biodiversity, okay? And so lots of questions can be raised here in terms of reporting. Not clear if or how the permitted activities will be documented, like within a database. Okay, and at what point does an activity negatively impact the in situ conservation of biodiversity? Okay, so it's really important to kind of understand these sorts of things that kind of open up when it comes to including or adding conserved areas to reporting in Canada and indeed globally. Okay, and what happens if an area no longer is recognized as meeting the criteria for a conserved area? If it's no longer effectively conserving biodiversity over the long term, well, it could be a candidate for delisting, okay? And the other avenues for here beyond biodiversity is that maybe a group, okay, like an Indigenous government or something like that decides that it no longer wants to be listed as a conserved area or as an OECM, okay? And so we need some kind of monitoring in place to determine whether a site continues to meet the necessary criteria to be recognized, and we really don't have that in place right now. Okay, again, this term has really complicated things substantially. Okay, so I'll skip this one because I kind of went through that, but I'll give you a couple examples of what's going on in Canada. So this is a map of the Northeast Newfoundland slope, okay, right here. And this is an important area that protects cold water corals and sponges. Okay, it's huge, 10 times the size of Prince Edward Island. Okay, and it was declared a fishery closure. And back in 2017, it was declared as, I mean, within a slew of a whole bunch of other fisheries closures, as one of Canada's first OECMs, okay, or conserved area. Okay, and I'll show you a picture of this now. Okay, but here's the problem. Yeah, identified in 2017 as a marine refuge by DFO. Okay, all bottom contact fishing activities are banned, but oil and gas exploration drilling are permitted in marine refuges. Okay, and in 2019, you can see that the area was open for bids, and we're talking massive amount of oil and gas. Okay, 4 to 5 billion barrels of oil estimated potential. Okay, 2020. Licenses were granted to explore, and in 2023, BP began drilling, right? But there's no system in place to monitor these kind of changes, right? But I would argue that this is a candidate for a conserved area or an OECM delisting, right? Because gas extraction, no surprise, is incompatible with in situ conservation, right? And so these are the areas that have kind of been opened up to bids in oil exploration and within the within the larger boundary of this marine refuge. So you can see that if this area is opened up, I mean, what are you going to do? You're going to start slicing it into pieces, or are you going to just delist it entirely, right? And again, this is not in the spirit of the CBD. This is not long-term, so the Convention on Biological Diversity, right? Other examples that Dan Krause and I have reported on, we're starting to see some things pop up in other provinces and territories, both good and bad. Okay, BC, there's evidence to indicate that they added or identified and declared a bunch of OECMs, but they're starting to scale them back. They have what are called, old growth management areas, wildlife habitat areas, and wildland zones. And a lot of these are areas that are included within Canada's protected and conserved areas database now, but they're questionable, okay? Boundaries can shift in these areas. They're open to logging, oil and gas, road building permitted, and they're easy to reverse. So again, it's not really dedicated to the long-term conservation of biodiversity. Okay, and there's some evidence to indicate that they're scaling things back or correcting, which is a good thing, okay, in terms of area declared conserved in BC. Okay, NWT is a little bit different. They're declaring, they have a whole bunch of conservation zones, okay, that are up here that could be classified as a protected area. Okay, these areas are, I'm colorblind, so I think that's gray, okay? But they have 41 conservation zones, and it's pretty clear that their primary objective is to conserve ecosystems and biodiversity. Okay, but these are actually declared as OECMs. And the only thing I can come to is that they may just not be dedicated to the long term, that they're kind of dedicated to every 5 years or something like that. Okay. Just to round things out, we're just noticing a whole bunch of changes. Okay, that 42% of conserved areas or OECMs were actually originally PAs or protected areas. Okay, so lots of changes taking place, but it hasn't been transparent at all, okay? And a lot of cryptic stuff going on, okay, when we start looking at the World Database on protected areas and things like that, okay? But we need to take this into account. Okay, it's really important that we start developing the right tracking and monitoring kind of strategies and have a discussion, okay, about whether countries should start revisiting their designations for OECMs and even protected areas, okay? And it's really important to start doing this now because we're only at about 850 declared OECMs, and there's going to be thousands and thousands of these added over the next 5 to 10 years, okay? So just to round things out, this is my last slide, but obviously in terms of next steps, I think that having some sort of working group, okay, put together through the Canadian Council on Ecological Areas, and for those of you interested in parks, the Parks Plus Collective, how many of you have heard of that? They offer some great training on this, okay, but a good idea would be to establish a working group to address these type of kind of tracking and reporting issues, okay? And we've recommended for nearly a decade Okay, that a lot of training should occur across jurisdictions, like within provinces and territories, to make sure that we're all on the right page about what an OACM is and what an OACM is not, and to share experiences, learning experience in terms of reporting as well. Okay. And we'll just kind of skip that one. All right. Kind of a little bit repetitive, but it's a really important issue that needs to be taken into account. And some of these challenges may not be a surprise because it's so new, but at the same time, there's a lot of things that we could be doing better in terms of reporting and tracking and things like that. So thanks for your time. Yeah. Yeah. Okay. So I have one question online. Actually, let's see here. As species decline and habitat loss have been increasing for the past century, if not longer, despite the fact that OACMs may have existed, which is true. Okay, so just because OACMs are being reported now, it's not like they're new. Often they're previous designations, okay, in some way that go back decades, okay? Does redefining the way we quantify protected land use conveniently allow us to feel better about how we are doing in terms of meeting agreed upon targets? Yeah, I mean, that's more of an ethical question and hard to disagree though, Alistair. I think that you're probably right? Which is kind of partly the job that I've tried to, and myself and colleagues have tried to take on, is to ensure that we do have some sort of minimum standard in place so that we're protecting areas in the true spirit and intent of the Convention on Biological Diversity and doing what's best for the long term what's doing the best for the long term for both biodiversity and for future generations of people that have to deal with the decisions that we're making today. We should be striving for high quality. Yeah.
So we're gonna take a quick break and we'll return at 2:40.
Okay.
Just to save a little bit of time. But if you have any questions for Chris in person, feel free to ask him over the break. And then yeah, we'll return at 2:40.
Check, 1, 2, 1, 2.
Okay, everyone. Welcome to the last session of the conference today. This session will be bringing together 5 early career professionals who will each present a 10-minute lightning talk on diverse topics with relevance to protected and conserved areas. Our first speaker is Jason Phoenix from the University of Waterloo.
Okay, hi everybody. As was mentioned, I'm Jason, and I'm going to be presenting my PhD research today, which is titled Investigating the Effects of Agricultural Legacies on Tallgrass Prairie Restoration. So for my talk today, I'm going to start with a general introduction to tallgrass prairies. So I'll talk about why they're important why they're important and some of the challenges related to restoring them. Then I'll get into my experiment, how it was designed, and some of the steps I took to initiate it this year. Then I've got some preliminary results I can share, and then we'll wrap things up. So we'll jump right in. Tallgrass prairies are a unique North American ecosystem that hosts substantial biodiversity and provide many ecosystem services. Unfortunately, they're also a highly endangered ecosystem because of the expansion of agriculture over the past couple of centuries. So they're now one of the continent's most endangered ecosystems, and Southern Ontario alone has lost over 97% of its native tallgrass prairies. So if we're going to save these ecosystems, we're probably going to have to restore them on former agricultural land. And there are a couple of problems with that. First, agricultural legacies can persist in the soil and vegetation community for decades, centuries, even millennia after agriculture ceases. And there hasn't been a lot of research showing how agricultural legacies impact restoration efforts. On a more practical note that's relevant to restoration in protected areas, we also have a communication gap between restoration science and restoration in practice. So restoration researchers often tend to emphasize the need for large-scale replicated studies that examine fundamental questions, whereas practitioners often require site-specific research that addresses a lot of the logistical challenges that they face, like funding limits, personnel shortages. So there's a big communication gap there. And I'm hoping that my research can address all of these problems because they're all problems that are faced by people who are trying to restore tallgrass prairies. So let's take a look at my experiment. So the main goal of my experiment is to study some of the most efficient and effective methods of tallgrass prairie restoration on former agricultural lands in Southern Ontario. And one of the goals I have is to try and understand how restoration success is affected by the amount of time since a site was abandoned. Ultimately, at the end of my PhD, I'm hoping that I can develop some science-based practical guidelines for large-scale tallgrass prairie restoration. So my project is going to have three components. The first component is going to be just to investigate the effectiveness of various restoration treatments in restoring native tallgrass prairie. Secondly, I want to look at each treatment's effectiveness in suppressing the growth of non-native plant species, which, as we'll see, is a huge problem. And third, on a more practical level, I really want to analyze the expected costs, resources, time, et cetera, that's required in order to do a large-scale restoration using the treatments that I'm going to study. So my timeline for the project, year one, that was this year, I did my baseline surveys, I prepared my sites, I sowed my seeds. Years 2 to 3, which will take me to the end of my PhD, I'm monitoring my research sites and I'll be compiling the results. In subsequent years, some future grad students will take over the project and they will, continue it on into the future. So I have 7 research sites in total. 4 of them are owned by Credit Valley Conservation. So I have 2 sites up at Upper Credit North Conservation Area, up near Orangeville, and then 1 site at Ken Willans and 1 at Silver Creek. I also have 3 sites that are owned by Rare Charitable Research Reserve, which is down in Cambridge. So those sites are called Sparrow Field, Newman Field, and Crabapple Field. And each of these sites was abandoned at a different point in time from the 1980s through to 2009. So that gives me a good range of dates so that I can study how the age of the site affects the restoration success. So each site's going to look something like this. I've marked out my plots that are 65 meters by 80 meters, and each plot is subdivided into 20 smaller subplots that are 10 meters by 10 meters. And the subplots are 5 meters apart. Of the 20 subplots, 16 will be receiving treatments and 4 will be controls. So the treatments that I'm testing will be combinations of the following. So different grass to forb seed ratios, that's 3-to-1 and 1-to-1 ratios, mycorrhizal inoculation, and annual mowing. And the controls I'm going to be using will be no preparation of the subplot. That's one type. I'll talk about my preparation methods in a moment. Or prepare the subplot, but don't seed it. So let's take a look at a few of the first steps that I took this summer in order to get the experiment up and running. I started with baseline surveys, of course, taking soil samples, doing vegetation surveys, which involved 1-meter quadrats to estimate percent coverage, and presence-absence surveys. The preparation of the sites mainly focused on elimination of invasive species or non-native species. So I cut and pulled non-native shrubs, and I also mowed each site in order to limit seed production by non-native species. I've been sowing seeds during the past couple of weeks so that they can overwinter at the sites. So I've been broadcasting the seeds by hand and then packing them down with a heavy roller. So I'm not very far into the experiment so far. I'm just getting it going, but I do have a few preliminary results that I can share from my baseline surveys that I took over the summer. First, from the presence-absence surveys, I found a large range of species present at these sites. Overall, each site had somewhere between 24 and 97 species present, which is quite a large range. Interestingly, I found no apparent correlation between the age of the site and the total number of species there. So I would have expected older sites to have way more species present compared to sites that were just recently abandoned, but I did not. And so that's something that's interesting and that requires a little more study. Ultimately, non-native species were dominant at 5 out of the 7 sites, with Kentucky bluegrass being the most prevalent species. It was present in every single subplot of every single site. So not exactly a happy picture. Now you could look at this and say, okay, well, there's still 2 out of 7 sites that had more native species than non-native species, which seems promising. But the picture looks a little less rosy when we look at the results of the Quadrat surveys. So in terms of percent coverage, non-native species just absolutely dominated. So when averaging over all of the subplots at each site, I found a minimum of 60% non-native species cover at every single site. And so there's a general trend, which is somewhat positive, of slightly increasing native species cover as site age increases. So older sites have slightly more native species. But when we look species by species, again, Kentucky bluegrass, the most prevalent species, an average of 44% coverage across all the sites. And of the top 5 species, only one of them is actually native. So mostly non-native species. Just wrapping up here, it's clear that my starting point for the restoration is not very optimistic. There are a lot of challenges that are going to be in my way. So all of the sites overwhelmingly dominated by non-native species. I haven't tested yet my soil samples, but I expect the soils will have been altered by agricultural practices, and that will impact the species I've sown. I also encountered lots of practical challenges, finding suitable sites, tight timelines, limited budget, and all of these things here. These are all things that people encounter when trying to restore this type of ecosystem. And so I'm hoping my research can address all of these issues. And if you remember, my ultimate goal is, by addressing these issues, to provide some sort of practical guidelines for some effective and efficient restoration methods for tallgrass prairies. So that's about all I've got. I just want to thank my supervisor, Stephen Murphy, as well as Rare and Credit Valley Conservation for providing me with my sites. And thank you to all of you. One question? Apparently we have time for one question if anybody has a question.
Hi, thank you so much for your talk. For when you're quantifying or when you think about it with the agricultural sites that are older that have been abandoned earlier, do you think like the native species were from the seed bank, like already there and like they've just been there for that long amount of time? Or do you think it was somehow, reintroduced or brought in by like animals, for example?
Good question. For anyone who's online, if you couldn't hear it, it was about whether native species at the sites were, somehow there in the seed bank already, or whether they were introduced later. Hard to say. It'll probably vary from site to site, species to species. It may be interesting to do a little survey in the surrounding regions of each site just to see what's there. So I'm not actually sure, but it probably varies a lot between species and sites. But yeah, thanks very much.
We're apparently waiting for our next speaker, so you'll forgive the pause for a moment or anything like that. I believe we have Andrew approaching now. There we go. There we go. All right, without further ado, I'll turn over to Andrew.
Okay, perfect. So, hello everyone. My name is Andrew Tanoot. I am from Wilfrid Laurier University, and my supervisor is Dr. Crystal Mew. And today I'll be giving a talk on assessing constraints to accessing national urban parks in Canada, a preliminary analysis. So, my presentation overview, I'll start with kind of an introduction to what national urban parks are, kind of work my way through my objectives, kind of introduce the survey I'm analyzing for my research, and kind of go through some preliminary results that I'll share with everyone today. So, an introduction. So, global and Canadian health challenges have been rapidly increasing over the past several decades as a result of urbanization, inadequate nutrition, reduced rates of physical activity, and the more recent COVID-19 pandemic. So, although concerning, research has shown that viewing, being, and having active participation in nature has the potential to reduce some of these health concerns. So nature is able to reduce concerns such as depression, anxiety, and self-esteem related causes. However, nature is also able to improve mental health conditions such as mood, blood pressure, and immune function. Although there's many health benefits of nature, certain individuals and communities are not able to access these health benefits because of structural, intrapersonal, and interpersonal constraints. So the concerns around health, urbanization, and inequitable park access prompted the Government of Canada and Parks Canada to expand the National Urban Parks program. So a national urban park, while there is no formal definition, you may hear me refer to them as an NUP or a NUP. These are large continuous natural spaces in close proximity to a city center. These spaces are concerned with conserving nature, connecting people with nature, and advancing reconciliation. So right now, there's only one national urban park in Canada, and that is the Rouge National Urban Park located in Toronto. However, in 2021, the government plans has committed to expanding the number of NUPs to 15 by 2030. So my research objectives. My first one is to compare population characteristics at an existing NUP site and a proposed NUP site. My second one is to compare and contrast structural, intrapersonal, and interpersonal constraints at an existing NUP site and a proposed NUP site. And my last objective is to provide evidence-based recommendation to Parks Canada on how to reduce constraints to NUP sites. My methods. So right now, I am currently analyzing a Canadian household survey created and administered by a larger project called ParkSeek. So ParkSeek, if we're not aware, is a pan-Canadian initiative used to gather and share information on population health impacts or health impacts of parks, protected areas, and recreational facilities. So this, or ParkSeek, is led by researchers at Wilfrid Laurier University and Western University. So this survey, I'll kind of move a little bit about the survey. So the survey has 5 sections, which we can see up there. And in 2023, a paper-based survey was sent out to Canadian communities that were a part of the ParkSeek project. Out of all the communities that received the survey, I decided to pick the town of Whitchurch-Stouffville since it's in close proximity to the Rouge National Urban Park and also the city of Victoria. I picked Victoria because it has a developed management plan and also it has a site picked out, which is important for my research. So taking a look at a few images, we can see the image on the left is the Greater Toronto area, and the area encompassed in the green boundary is the Rouge National Urban Park. At the top, you can also see the town of Whitchurch-Stouffville and see it's in close proximity to this park. The image on the right, we can see Vancouver Island with Victoria at the bottom, and we can also see the one which indicates the location of the proposed National Urban Park in the Victoria area. So the one represents the Fort Rod Hill and Fisger Lighthouse location. So a few more images, we can see the Rouge in the front, and in the background is the Greater Toronto area. And here is the Fort Rod Hill and Fisger Lighthouse location. So some preliminary results. Preliminary results, I'm kind of in the process of going through it now. So I'll share some basic kind of descriptives for today. And kind of my next step is kind of comparing and contrasting the two cities and doing more bivariate and multivariate analysis. So 228 samples or respondents combined between Whitchurch-Stouffville and Victoria. We can see the breakdown: 82 men, 141 women, 2 people who identify as or self-identified, and 3 people who did not reply. The average age was 55, and the ethnic background is right there with a majority of white Caucasian followed by East Asian and South Asian respondents. So this question is particularly important for my research as it asks the respondents what impacts or constrains their ability to visit protected areas. So there's 32 constraints. Each constraint had 5 options that ranged from not at all impacted to extremely impacted. I was able to convert those string values into numeric responses and to calculate a mean. So I organized the top 5 constraints and the bottom 5 constraints by mean. So the top 2 constraints are structural constraints, which is consistent with recreation and tourism literature. So some other questions, I don't really have time to go through each one, but a main takeaway from these questions is that respondents and their children are not spending enough time in protected areas to meet their overall needs and well-being. So I'm excited to look into this a little bit further to kind of understand what is happening in Whitchurch-Stouffville and Victoria, and hoping that a national urban park will bring nature closer to home. So kind of a discussion and conclusion. So since the National Urban Park Program is a relatively new initiative, I'm hoping that my research is able to inform and support Parks Canada in kind of the development of the parks. I'm also hoping that I'm able to connect Canada's diverse urban population with nature and the health benefits nature provides. Last couple points, hoping that my research is going to be able to be helpful for a broad range of people working in conservation and other professions such as healthcare. And I'm hoping above all to address the limited understanding of constraints that restrict people from accessing nature in Canada. So just want to say thank you for everyone for listening today. Thank you to my supervisor, Dr. Lemieux and Catherine Reining for their help. And also want to thank the respondents for their time to fill the survey, because without them, we wouldn't have data to analyze. Thank you.
All right. We are ready for our next speaker, Maya Alachi, and she's from the University of Waterloo. Sure.
Hi everyone, my name is Maya Adachi and I'm a master's candidate in environmental studies. Today I'll be presenting my undergraduate honors research project, which is about Phragmites' impacts on biodiversity in Tommy Thompson Park, which is located in Toronto. So just a background on what Phragmites are. They're an invasive species in North America. They spread super quickly. They form dense monotypic stands, which can drastically alter the landscape and affect wildlife and vegetation community structures. Management of Phragmites typically involves mechanical methods, which includes cutting, burning, spading, mowing, and chemical herbicide treatments, or a combination of multiple methods over time. So just some context in terms of the Phragmites' impacts on wildlife. In the literature, the impacts are quite contested. There's no clear answer. But with regard to reptiles and amphibians, the dense stands caused by Phragmites invasion can pose physical barriers, reduce nest site availability, nesting options, and hatching success, particularly for turtles. But on the other hand, some studies suggest that Phragmites may actually provide suitable habitat and cover to reptiles, including those at risk. Moving on to mammals, beavers, muskrats, and small rodents have been observed to utilize Phragmites for food, habitat construction, and emergency cover from predators. And finally, birds that are considered generalists are not typically affected by the presence of Phragmites, and they're able to utilize it as a food source or a suitable roosting habitat. But other studies have found that even at-risk bird species like bank swallows may utilize Phragmites as roosting habitat as well. So there's lots of contesting research surrounding this topic, which I'll discuss more throughout my presentation. So my study site is located in Cell 1 wetland in Tommy Thompson Park. Tommy Thompson Park is an artificially created recreational park situated in Toronto and managed by the Toronto Region Conservation Authority. My study is the Cell 1 wetland, which sits atop a decommissioned confined disposal facility. So it was artificially created into a wetland in 2003, and today it supports a biodiverse vegetation and wildlife community. Phragmites first established in the park in the early 2000s, and in 2018, the TRCA implemented the Phragmites management strategy. And the strategy is still ongoing. It takes several years to manage the species. But I just wanted to show the difference in the photos in the cells in 2018 when Phragmites' presence was at its peak. So all this red is Phragmites. And after a few years of management in 2021, the green represents the native species and the red is the non-native, so mostly Phragmites, as well as like purple loosestrife and other invasive species. So they've done a lot of management in just a few years, and you can see the clear difference in those two images. So methods. We divided the phases of management into 3 phases. So the first phase is 2006 to 2011, when the initial restoration of the wetland mostly supported a native vegetation diverse community. The second phase is the Phragmites dominant community from 2012 to 2017. And the final phase is the Phragmites controlled community change with active management of Phragmites. So that was 2018 to 2021. And I'll refer to these phases as phase 1, 2, and 3. The data I used consisted of aquatic vegetation surveys, wildlife surveys, and breeding bird surveys, all provided by the TRCA. For the purpose of this presentation, I'll only discuss the wildlife results. And the wildlife surveys were conducted by volunteers once per week year-round, and a majority of sightings occurred between April to November. Surveys typically consisted of a 1-hour listening and observing period in which volunteers walked the perimeters of the wetland and recorded the species and the number of individuals of birds, mammals, reptiles, and amphibians. So here are the results. We have species richness represented by the bar graphs, and abundance is represented by the dotted lines. And as a reminder, phase 1 is the initial restoration, phase 2 is mostly Phragmites, and phase 3 is during the management period. So starting with herpetofauna, so mostly reptiles and amphibians, this is the turquoise bars. The number of individuals was highest in phase 1 with 55 individuals, and it decreased over the phases. So you can see it's represented by this line here. There were only 5 mammal species in my study, so it's quite limited. That's represented by the purple graphs, and abundance was highest in phase 2 with 98 individuals. Oops. So this triangle here, highest in phase 2. And In terms of bird species, there were 78 bird species in total. Species richness remained the same for phases 1 and 2, but abundance was the greatest in phase 1 with over 12,800 individuals up here. And it remained considerably high in phase 2, but as you can see, there's a significant decline here between phase 2 and 3 in terms of the abundance of birds. But that doesn't show the full picture, so I also calculated species diversity. And in terms of reptiles and amphibians, phase 2 was overall the most diverse and even. Phase 1 was the least diverse, even though it was the most abundant in individuals. For mammals, despite abundance being highest in phase 2, it turns out phase 1 was the most diverse and even. And with birds, you can see here, there's a huge difference in terms of between phase 2 and 3. So phase 2 had the highest species diversity, but compared to the last graph, which showed that big decline in abundance, in terms of diversity and evenness, phase 3 was actually pretty high in diversity value. It was also the most even across the phases. So for conclusions, there's some key findings. The first is that different taxa respond differently to Phragmites, so the data doesn't show a clear trend across the phases. And as well, many external and indirect factors also come into play, so it can be difficult to determine the direct effects. As previous studies have suggested, mammals may benefit from Phragmites as a food and habitat resources, and my study also reflected similar results. The findings of the study also suggested that herpetofauna were not so much negatively impacted by the Phragmites itself, but rather by Phragmites management. So it's important to consider at-risk species when managing Phragmites and the different methods that are employed. With birds, I didn't discuss the breeding bird surveys today, but despite the final phase being the lowest in abundance in terms of total individuals, the breeding bird nest survey showed that the final phase had the most nests. So there was a discrepancy between different data sets, and that can be a challenge in determining how exactly birds utilize Phragmites and how they can be impacted. And finally, as I mentioned in the beginning, the management plan is still ongoing. My research was conducted during TRCA's 4th year of Phragmites management, so most wildlife species will likely require time for their populations to recover in the new habitat. So long-term monitoring and management will be necessary to support the restoration of native vegetation, suppress Phragmites reinvasion, and sustain local biodiversity. Thank you.
Have to move to the next talk, Maya. Thank you very much. That was great. That was great. Finished right on time, which is even better.
Our next speaker is Erin Postenka from Laurentian University.
Hi, my name is Erin Postenka, and I am a first-year master's student at Laurentian. And I'm being co-supervised by Dr. Jackie Litzkus at Laurentian University and also by Dr. Christina Davey at Carleton University. And so today I'm going to be presenting on my proposed work, and the title of my talk is Rare Events and Long-Term Datasets, a unique opportunity to study the impacts of wintertime wetland drawdown on turtle populations. So wildlife management is incredibly complex. We're dealing with wild populations that both exist within dynamic systems and are dynamic systems in and of themselves. And these wild populations are constantly being acted upon by both intrinsic factors that relate to the species' evolution and their life history, as well as extrinsic factors. So their interactions with both their abiotic environment, for example, the climate, and their biotic environment, so the other species that cohabitate within their ecosystem. And so typically populations fluctuate around a more or less stable population size, and the magnitude of those fluctuations will depend on the species life history. So this is just kind of a generic graphic. It doesn't represent turtle populations. They tend not to fluctuate too much because they recruit quite slowly to the population. However, from time to time, we have stochastic events which occur, and these are short-term, small-scale disturbances that lead to either slight increases or slight decreases in population size. And then on the extreme end of stochastic events, we have catastrophes, which are quite rare. So catastrophes are mass mortality events which result in the rapid and substantial reduction in population size. And so there's no defined threshold that says this is a catastrophe and this is not a catastrophe. Some researchers have proposed that over 50% reduction in population size constitutes a catastrophe. However, with long-lived reptiles like turtles, a much smaller decrease in population size can be just as dramatic and just as catastrophic. And so catastrophes pose a significant threat to population persistence, and they have been increasing in frequency, at least among reptiles. So that's what this graph shows. The bar graph shows an increasing number in the reports of catastrophes in reptiles, as well as the black dotted line, which shows an increase in the number of citations about those events. And so these trends are expected to continue into the future as we deal with climate change and more frequent extreme events. So it's incredibly important to understand how both populations and communities respond to catastrophes like this so that we can better inform our management approaches and our recovery strategies. So some species can quite readily recover from catastrophes. These tend to be the species that reproduce quite rapidly and recruit to their population. However, turtles' life histories are very slow. They're characterized by very low survival during the juvenile stages and delayed maturity, which is then compensated for by having a very long lifespan as adults and having consistent reproduction year after year. But this means that they recruit to their populations very slowly and therefore cannot easily recover from these major catastrophes. So long-term data sets are absolutely essential to the study of the effects of catastrophes. So because by nature we can't predict catastrophes, we need to have this long-term data so that we have a picture of the population both before the catastrophe has occurred as well as after. So we need this long-term data and then this element of chance, whether that's luck or bad luck, to actually witness a catastrophe within that long-term data. And that provides an opportunity not just to study the existence of the catastrophe, but the effects on the population long-term. And so Ontario's protected areas provide an opportunity to implement long-term studies, which then increase our chances of witnessing a catastrophic event and being able to study those long-term effects. So my proposed study site is Pinery Provincial Park, which is located on the south shore of Lake Huron and where I've been privileged enough to work for the last 6 summers. And so Pinery is home to the Old Asable Channel, which is a more or less linear deep water marsh or pond-like habitat, which is currently home to 5 different turtle species. And at Pinery, there's a long-term mark recapture program of Pinery's turtles, which has been ongoing since 2008 when Dr. Christina Davey was doing her doctoral research at the park, and has been since picked back up by park staff in 2019. So every turtle that we encounter receives either a unique notch code or a pit tag so that we can identify it later. So here's our long-term data. And then during the winter of 2010-2011, we had our chance event, which was a channel drawdown potentially resulting in a population catastrophe. So what occurred was there's some concern about water levels and public safety. And so a beaver dam was removed, and this inadvertently led to the drawdown or drainage of an entire section of the channel. And so this is problematic because winter drawdowns have previously been implicated in mass mortalities of turtles. And this is because turtles are ectotherms and require a very specific set of conditions to be able to survive the winter. And so these conditions include sufficient moisture. So the vast majority of turtles overwinter under the water, and so this prevents their desiccation. They require temperatures that are both high enough to prevent freezing, but also low enough so that they keep their metabolic rates low, and this prevents the accumulation of toxic metabolites in the bloodstream. They also require sufficient oxygen. So many species like painted turtles and snapping turtles are incredibly anoxia tolerant. However, there are other species in the park that are not. And there's also a great deal of variation within those tolerant species. So for example, hatchlings and juveniles are less tolerant to anoxia than adults. And then finally, they require shelter from predators. And so predators have been the cause of mass mortalities in turtles in the past, when either the turtles are exposed by a drawdown or they're concentrated into the remaining habitat. So my research questions are, number one, did the drawdown actually result in a mass mortality event? Number two, are there any lasting impacts on either turtle population demography or community composition? And then finally, are painted and snapping turtle populations, which are the two most common species in the park, are they viable going forward? So our plan is to continue the mark recapture program, which is currently implemented at Pinery, by using baited hoop traps and active surveys to catch turtles, give them a unique identifier, and then measure them. And so to determine whether a mass mortality event occurred, we'll be looking at recapture rates. And so if a mass mortality event did occur, we would expect lower recapture rates post-drawdown compared to pre-drawdown, as well as in the impacted area compared to unimpacted areas. To examine any lasting impacts on turtle population demography, we'll be looking at things like their abundance, biomass, age and size class ratios, sex ratio, and survivorship. Most of this will be computed using program MARC. And then to get at community composition, we'll be looking at things like species evenness and diversity, as well as relative biomass. And then finally, we'll be conducting population viability analyses using Vortex. So the significance of this research is that it has implications for water level management. So winter drawdowns are actually a quite common management practice, not necessarily within protected areas, but they do occur within Ontario. And this is often to control aquatic vegetation that might be invasive or a nuisance, or to manage for sport fish or waterfowl. Additionally, beaver dam failures do occur as well, and these may increase in frequency under climate change when we have more frequent extreme weather events, say extreme rainfall that could wash out a dam. And then finally, depending on how the populations and the communities have responded to this disturbance, this will help us to inform recovery strategies for at-risk turtle species. And then I just want to acknowledge our partners at Pinery, Alistair McKenzie, who's been supporting and championing this project from the very beginning, and Sarah Tremaine Douglas, who's been absolutely integral to this next stage of our project. So thank you for listening. If you have any questions, I'd be happy to correspond over email.
Okay. Our last talk for the afternoon is going to be given by Mary Yu from Laurentian University.
Hello, everyone. My name is Mary Yu, and I am a master's student at Laurentian University. I'm here to present the power of long-term data sets for monitoring populations of long-lived turtles. And my collaborators for this project are Sonia Bowles from the MECP, Jim Trache from MNR, and Dr. Jacqueline Litkus, who is my supervisor at Laurentian University. So let's get into it. All about turtles. So turtles have a bit of a reputation for being dinosaurs, you know, this idea that they can live forever. And though that's not far from the truth, all of our Ontario turtles are incredibly long-lived, which is especially important for their life history because of that delayed maturity. And I think my colleague Erin has done a really great job at going in detail about this. I'm not going to go too far in, but something I just really want to highlight is that need for high adult survivorship in order to counter that low recruitment rate. This life history strategy has allowed turtles to live for over 200 million years through the age of the dinosaurs. Yet in today's modern world, turtles are struggling to adapt to rapidly changing environments and threats. So unfortunately, all of our 8 native freshwater turtle species living in Ontario have been listed as at risk in Canada. So let's talk a little bit more about long-term data sets. For long-lived species like turtles, having a long-term data set is so valuable when doing population analyses. You can actually see how that population changes over time. You can actually quantify individuals within each age class because you might find a juvenile you marked 20 years later. When we look at a population of turtles, you really can't fully understand the outcome of recovery or acute mortality events without looking at that population over time. Without time, we can't really know for sure how these events will actually impact the population. And so our problem is time and that we can't go back in time to get that data. Now, danger. Danger is always present when it comes to sensitive species. Some primary threats for turtles include predators, individuals like raccoons, otters, fishers, and other weasel-type mammals. Predators especially can greatly impact turtle populations, especially if they target those adult individuals. Now, a not so uncommon threat is motorized vehicles, so vehicle mortality. This is from cars, trucks, ATVs, bikes, what have you. And now, not a danger to all turtle species, but an increasingly scary one is illegal collection and poaching. And let's be real, turtle's not going to be faster than a human trying to capture it. So, Parks has done a great job at making a lot of significant habitats protected areas. And this is really important because these protected areas are no longer at risk of degradation. Yay! But let me ask you, is this enough? You know, we've converted this area to become protected. Is it like I no longer need to go oversee or monitor the sensitive populations that live in this ecosystem? Yeah, unfortunately for turtle species, although maybe their home is protected, other threats still remain. Things that I've already mentioned, like predators, vehicle mortality, human disturbance, and of course, climate change are all factors that can greatly impact a turtle population. So I bet you're wondering now, what can we do? Well, one thing we can do to take action, we need to get our boots on the ground. We need effective and long-term monitoring in order to understand how these turtle populations are changing over time. We need ongoing or continual monitoring so that these turtle species don't disappear after we've deemed an area protected. Long-lived species like turtle need continual monitoring so we can actually understand how these populations are changing over time, how they're actually adapting or not adapting to the threats in their environment. It also allows us to detect acute events early. If we know maybe a trail or a road has extremely high mortality rates, maybe something we need to consider is road mitigations, ecological corridors, or maybe even closing off the road for a month. Not only does long-term monitoring allow us to detect these acute events early, but it also allows us to intervene. So now I'm going to go into a case study that pertains to my master's project that I really hope will bring into focus the value of long-term monitoring. So a long-term study has been done on wood turtles. Now, wood turtles are endangered in Ontario, globally, and threatened in Canada. So the population that I'm studying is in central Ontario, and amazingly enough, it's been studied since 2000. So over 24 years of data has been collected for this population. And with this data, I can confidently tell you that there are over 300 individuals and evidence of recruitment, which is super exciting and something I likely would not have been able to say with only a few years of research. So my first field season was this past spring of 2024, where we did mark recapture surveys as well as radio telemetry. And since I've been following this population since the spring, in fall of 2024, unfortunately, we encountered a depredation event that took 9 adults and 3 juveniles from our population. So the juvenile mortality, it's really unfortunate and sad, but it's pretty common, more often than not for turtles. What's really concerning though is the adults. 6 males and 3 females were removed from this population because of predation. So yeah, that's incredibly unfortunate. What's the solution? Well, as a student, this means constructing a population viability analysis, or a PVA. And this population demography and analysis will contribute to the first chapter of my thesis. And I bet you're wondering, what does a PVA actually tell us? Well, it basically forecasts the future trajectory of this population based on all of our data. Data like the current population numbers, how many males, females are in this population, how many individuals within each age class, what is the rate of reproduction or mortality, is there immigration, emigration? All these different variables go into producing an accurate population model to simulate what the likely outcome of this population will be. And lucky for me, I have long-term data to actually inform my PVA, which is amazing for sensitive species like turtles because of that slow life history. Now, some of these parameters you likely wouldn't be able to capture unless you have years of monitoring. So unfortunately, a lot of populations don't have that information to inform a quality PVA. Now, I bet you're wondering, how could this help you? Well, PVAs are an extremely valuable tool for land managers. It helps them make critical decisions related to the management of the land as well as the species. Since this PVA is informed with over 20 years of data, it can be used to inform other similar populations of turtles that lack that long-term data. It also means opportunities for future ecological stewards. This data is important and needs to be collected. It can be used for training because it targets parameters that highly influence the recovery or the extinction of a species. And of course, this work will directly contribute to the Ontario Parks Science Strategy. Now, before I let you go, I have one last thing I really want to highlight, and that's teamwork. Now, I'm sure you've all heard this saying, teamwork makes the dream work, right? And that really could not be more true with this project. This project started with the MNR, with Jim Troche going out and collecting mark recapture data. Then the MECP came in, decided to take on this project with the help of Laurentian University. So now we have experts from the MNR, MECP, and Laurentian all working together to inform and make decisions about this endangered species. We're all sharing knowledge and resources. Now, not a surprise, equipment and labor is very expensive. So being able to share resources is is an amazing and practical solution to budgets. And of course, we need to emphasize the importance of knowledge keepers. For the land, these are your zone and park managers. For the species, these are your field ecologists and academics, like professors and students. And the history, these are your Indigenous peoples. All of these individuals play an equal and critical role when it comes to species management because they all carry important knowledge that can inform conservation and restoration strategies. And we can't make sound decisions if we lack essential information. And with that, I want to thank you for listening to my presentation. And if you have any thoughts or questions, please feel free to reach out. My email is listed. Thank you so much.
All right, thanks a lot, everybody, for that. I will, for Mary, I'll apologize. I got hungry. That's what happened to your turtles. If that were true, actually, the Jackie Litska's awesomeness would actually smite me down as I'm here actually today. Okay. Fortunately, she's online, so it's like, it's not immediate. I want to thank everybody who presented today, especially our early career folks. One of the reasons why I like sort of having this opportunity with Casiopa is it gives people a chance to start thinking about sort of what they're doing in terms of cutting edge research and things. And that's sort of the next generation, right? It's cliche, but it's true. You want to make sure that people get a chance without feeling a huge amount of pressure. It's a relatively modest sized meeting, which is always nice to start out from there. I started out myself that way. And it's nice to hear what people are doing. So I really appreciate all of you for coming today for that. My remarks concluding are not going to be long. I have witnessed actually at a different meeting actually once where somebody was supposed to talk for like a couple of minutes, tried to go on for an hour and a half. Yes, an hour and a half. And by the time they finished, there was nobody left but the porters. Everybody else was in the bar. So, I mean, you know, that had to be embarrassing. Although I don't think they noticed, which was kind of interesting. I will thank again sort of all of our speakers from Joe Bennett on upwards. Really appreciate it. Everything's sort of there. It'll be recorded and put up online. I did want to end off today on a somewhat wistful note, not a depressing note, but a wistful note. This particular forum was originally started by several people, especially those within my home department of what is now the School of Environment, Resource, and Sustainability. Late George Priddle was one of them. George Francis is still with us, was part of it. The predecessor to this was Parks Research Forum of Ontario, PERFO, and that was run by Gordon Nelson. And Chris Lemieux, of course, worked for Gordon. I think I actually worked for Gordon too, even though I was a professor, but I'm pretty sure that was the case. Gordon passed this last year, and he was a big part of the reason why sort of this thing exists. So I wanted to acknowledge his passing and our gratitude with the fact that he started and carried it on for so long. So as I say, I don't want to end off on anything other than to say that sort of it's nice to see his legacy is carrying it on. With that in mind, I want to thank Eric, our AV professor. Thank you, Eric, very much for doing it. For Hillary and for Stephanie for sort of running the show around the place. Thank you very much for doing this as well. And with that, I'll consider it concluded. For those of you in presence, they kick us out soon enough, but do take stuff home, whatever's left actually out there. Those online, again, thank you very much for joining us. It's really appreciated. You're about to see me disappear. Actually, I'll go back and actually shut the feed off. Thanks so much. And I'll alert everybody as to when this meeting actually is up on our YouTube channel. It'll be a few days. Thanks a lot. Thank you.